Hey y'all, this is Precal12 study session 2. We're going to get it rolling here, and yeah, so let's get through some questions. All right. So we want to start on where we'll just go right straight where we left off. Is that cool? Yeah. What number on unit 3? Is that what we were saying? Unit 4. Unit 4, that's right.
Oh.
Unit 4.
Oh yeah, and you have this recent stuff, starting with like the sequences and like the hyperbolas. You gotta go over that.
I would say too. So the hyperbola stuff we did yesterday, pretty good.
Okay.
Yesterday, and then
it's on the podcast.
It was. And then on the actually the beginning of that podcast, there were 2 problems that I just said, hey, be very careful on. These were 2 that were not really on the review. So that's just kind of a heads up that I would just kind of watch. Just watch, especially those 2. Also, the study or the formula sheet has been updated. So this is actually different than the one that's there. But I put the new and updated one on campus, so you can go and check that out. Just making sure that you kind of know where everything is, so you're not trying to spend a lot of time looking for it there. But we can go through ones on unit 4. Those ones were, you're right, that was probably the number 1 unit that we struggled with. It's just a tougher one there. But let's look and see what it says, and we'll go through it. It says find the sum of the infinite geometric sequence. So any thoughts here?
We'll switch the whole number.
Mm-hmm.
Oh well, you gotta track the sequence on the bottom, right? So it would be times 3 on the bottom.
Times 3 on the bottom, good. So really the ratio that we're multiplying by each time would be what as we go? Multiplying by 3, right?
Yeah.
I like that. And if it's on the
like
bottom,
1/3.
there you are, 1/3.
That's our what? Our R.
That's our R.
Okay.
Mm-hmm. And remember, this would be an R because it's geometric. It's because we're multiplying. If we were adding by a specific number, that would be more arithmetic. It'd be something a little bit different. But with this, we're looking at a ratio of 1/3, and we understand that it says find the sum of the infinite geometric sequence. Okay. Now, if it's infinite, we remember, and I believe it's on the formula sheet there, that it actually says infinite geometric series, which means that it's A1 over 1 minus R. And that would be the sum of the infinite goes to infinity.
So it'd be -7 over 1 minus 1/3.
1 minus 1/3, nice. Yeah, -7 over on the top. And what would be the bottom?
2/3.
Yeah, that's exactly right. We got 2/3 there on the bottom. That's good. And any thoughts again on how we can simplify that? Good, yeah. So we got -7 multiplied by the reciprocal, which is 3/2. And that would produce what here? Good, -21/2. That'd be our sum. That one's not as tough. The second one can kind of get a little tricky because of the equation. This one tells me to find the sum of the first 10 terms, right? And oh, by the way, I'm assuming that we just start on number 1. I'm sorry. If you have other ones that you want to do, this is y'all's thing. So just tell me if you've got other things that you want to go to there. Is 2 good?
Yeah.
So on this one, it says find the sum of the first 10 terms, right? And it gives us an equation. So any thoughts here of what we could do?
It's geometric because it's like to the something power.
Great, yeah. So it's geometric. I like that. Good, Kendall. And then what else?
So do you have to plug in like 10 for n? Since the first 10 terms.
Mm-hmm.
Okay.
Not for necessarily the equation. If I found the 10th term, you'd be right. You'd plug 10 in for n.
Okay.
But in this one, we want to find the sum of those 10 terms. So instead of doing 1 through 10 and then adding them up, what could we do? correct. So the sum of the finite geometric sequence, right? So this would be S of 10 is equal to A1 times 1 minus R to the N all over 1 minus R. Right? What would be A1 here? Well, good.
And would R be negative 1/2?
Correct. Good. The one thing that I would say, just to be careful on here, is when you do the 1 minus negative 1/2, and then the N would be the 10th, right?
Yeah.
But when you do this, make sure don't make that positive yet, because the power must occur first before you do the 1 minus that, okay? And then we do 1 minus negative 1/2 on the bottom. More or less, it's just a lot on this. But once you identify like the right formula and you show work, you're going to get credit back for this once you show it. So we could just do negative 1/2 to the 10th here. I'll just do it right here on my calculator, and y'all can do it too. Go negative 0.5. We want to make sure that's in parentheses too. I forgot that. To the 10th. We'll do 1 minus it here. Are y'all good with plugging this stuff in?
Yes.
From here. You want me to keep going, or?
Yeah.
There. So we got 1 minus that. And then we can multiply by our first term, which was 12. Yeah, there you are. 12. And then I'm going to divide by 1 minus 0.5, I think is what it was, right?
I think it's minus negative.
Minus negative. So it's really 1
Plus.
plus. And the reason why I can change the sign here is because there's no exponent down there, right? So it doesn't really matter. Oh, well, whereas at the top, you want to make sure you want to
Do the exponent first and then.
Correct. Good. I got 7.99.
And it said round to 2 decimal places, so should that be like 8? Or would you like it to, you like it to just keep
I think it's just 7.99 there. That's a good question on that. Good. All right, we got through 2. Number 3, what do you think on 3? This is the tough. I would say one of the toughest ones right here. Okay, I think it's on your formula sheet, the NCR formula. You see that there? Put it on the other side. Did I not put it on there?
I think it's on the updated one. Maybe.
I think I did put it on there.
What is that formula though?
So this, whenever I'm finding, so there's like the binomial theorem where I can expand all of it.
Yeah.
And like expand it out, and then everything's there would be 1. If I ask for 1 term, like just 1, then this allows me, instead of expanding all of it out, it's a much faster way to just find one of those terms. Right? So if I have NCR, x to the n minus r, y to the r, that's the formula to be able to identify what this term will be. Okay? So really, it's funky. It's a little funky there. N is always the highest exponent of what the binomial is taken to, whatever power it's taken to.
So it would be
Right.
8 for
8.
n.
Yep, that's exactly right. So we have 8, C. I'm gonna the R we don't know yet, right? This should be 8 minus something, and then Y to the R. Any ideas of what R would be here? Here's the hint. If I said find the 5th term, it's always that whatever term it is minus 1. Okay? This is actually easier because you can see the formula here. and kind of match it up with what they're asking for. Any thoughts of what R would be then? I see Y, you subtracted by 1, right? But it's
Wait, can you go over that one more time? Like, how do you find the R?
Yeah, the R, normally, if I say find like the 5th term, you would then do 5 minus 1. I think that is a little tougher than what this is. This is much easier because as I look at it, they've already given me what the Y to the R power would be based on the formula. So you'll see that Y is already to the 5th, right? And based on the formula, Y is to the R power. So guess what? Y is going to be to the 5th. Good, which means that R is
5.
Exactly.
Do you always just look at Y though?
Always look at the Y.
Okay.
Just based on the formula, and this again will be given to you. You're just simply matching it up there. What's up, Parker?
What's up?
Welcome to the party.
Hello again.
I was just bragging on y'all yesterday.
We killed it.
Y'all killed it yesterday.
Oh God, I don't know how to do this. Wait, just kidding. I revert my cursing. Retract.
Yeah, okay, so just so you know, we're on unit 4.
Yes.
We just started. I've done the first 2. I'm podcasting right now.
Sweet.
Although today I'm trying to be a little bit more, I'm really here for y'all, the people that are here, but those that can't make it, again, I just try to put it on a podcast for them.
Truly, just please not through all of them.
Yeah, we are.
Okay, cool.
But just so you know, you could always go back to numbers 1 and 2.
Yep.
Really, to be honest, it's not tough once you know the formula, and you'll have those formulas there. Once you get through numbers 1 and 2. What I'm going to do though is I'm going to backtrack through number 3, mainly because I think I thought this one was one of the tougher ones. But we recognize that anytime we're trying to find one term of something, I'm going to give you this formula right here. Okay, it's on the formula sheet. Check it out on the new formula sheet. It's there. But basically, this will allow us to find what the term is of x to the 3rd, y to the 5th from this here. Okay. So we recognize that y is to the 5th and y is to the r in the formula. Therefore, 5 is r. Okay, because as we match up the formula to what was given, we recognize that 5 and r are the same. Okay. So that's why we plug in 5 in for r, and n is always the highest exponent. In this case, we recognize that it's 8. Okay. So we have 8c5, x to the 8 minus 5, right? Because 5 was r, and y to the 5th. Okay. So really what we have simplified is 8c5, x to the 3rd, and y to the 5th. Right. Is everyone okay so far? All right, so now what we're going to do is just on our calculator. This is something just to kind of keep in the back of your mind. Does anyone know how to find the NCR thing? Great. Nicely done. That's exactly right. So we're going to put, and before you put in go to the math part, just plug in the 8 first, because you know that's going to be what will become first here. And then we'll go to the math button, go over to the probability, go down to NCR, and then just put 5 in. And literally, that's how you get that number. Okay?
And then, so how do you, oh, well, that's just your coefficient.
Close. It's a little bit. And here's why. 56 matches up to that part right there. That's gone. Because that's 56. That's on a calculator. What is x, or the first term in this case? What goes in for x?
3.
3x.
And
Good.
2 for the y.
Good. So 3x goes in for x. So that's going to be to the 3rd power. And anytime I plug it in, I put 3x, and then that'll be to the 3rd. And then what goes in for y?
2.
Yeah, 2y. Good.
And then you multiply them all together.
Correct. So, and really, because they just want the coefficient, you know that 3 is going to be to the 3rd, as well as x to the 3rd. 2 is going to be to the 5th, as well as y is going to be to the 5th. And then once I get those, I just distribute all those or multiply them all together. Okay?
Can you go back? How did you get 56?
Oh, good question. So that's strictly like the 8C5 here. That's straight from my calculator. So when I plug that in, which if I go there, just go to the math button and go to probability down 2. And then I can just plug those in.
Okay.
8 and 5.
So then you got 56, and then you did the x to the third.
Yeah, so once I do 3 to the third, what's 3 to the third? 27, yeah. So we got 56 times 27.
Wait, I'm sorry, where'd you get that 3?
The coefficient in front of the 3x.
Oh, I got you.
Makes sense. And 2y would go in for y down below.
Okay.
Oh, so you're putting that in this equation?
Mm-hmm. That makes sense?
Okay. And so then you have, I got you.
So it's 27x to the third, basically.
Nice. And what would be 2 to the fifth? 32, good. And we just say 32y to the fifth. Nice.
Okay. So then what do we do with those two coefficients in front?
So yeah, literally, one thing don't just be careful on, do not distribute 56 to both of these because there's no plus sign in the middle.
Right.
Does that make sense? So literally you'll just do 56 times 27 times 32.
Okay.
Cool. You just go here, 56 times 27 times 32, enter, and there you are, 48,384. That would be your, that would be it there. Cool.
X to the third, y to the
X to the third, yeah, exactly. Good. X to the third, y to the fifth. Bye. Does that make sense?
yeah.
That one, I would say there's one of those on the test. And it's kind of one of those you just gotta, and show work, right? Because if you mess up on a little part, like, I don't know that.
It's just plugging it into that formula, isn't it?
Mm-hmm. Exactly right. Mm-hmm.
Okay, what is the original formula?
This one here.
Yeah.
NCR, and then it's x to the n.
I want to do something here.
Y to the r.
What is it for?
Those that are at home right here, you could go and check this out. But I want to show those that are in here in the study session. I want to show you all the formula sheet if that's cool. I just wanted you to know where it's at. So when you see that one, you just know where to go right away. Cool.
Do you have an extra formula?
This one's actually a new one.
Okay.
This is the one you're going to actually see on, it's right up here for this. It's very similar. But you'll notice like it has the foci stuff, right? Because I heard y'all from yesterday. It's got the log stuff.
Yeah.
It's got the compound continuously and the regular compounded formula. They have the horizontal asymptote stuff, the end behavior stuff. Cool. And then here's the NCR. You see that?
Yes.
And so when you see that, you've got it here. Just go straight to that when you see this one. But it'll be right here. And you'll be able to have it there. Okay. It's actually a lot nicer than what I thought I was. I actually label a lot of where the formulas are used. You know what I mean? Like a lot of them are, like I even tell you.
So yeah, like that's my thing. Knowing the wording like the wording of the problem to know. Like,
Yeah.
What I would do is 100% understand, 100% agree. I think this will help you because I actually label like here's where it's used. I would say tonight when you're reviewing, like it would take like 10 minutes maybe. Go through each one and be like, okay, what formula would I use for this one? Oh, okay, it'd be this. What formula do I use for this one? Okay, it'd be this.
So
that might help you there.
and so I see it's up there, but like on this one, N is 8 because that's the highest. Okay, and then R is 7. Like because it says N minus.
So if I say what's the third term of this sequence, you would do 3 minus 1, which is 2. Okay. However, notice I asked the last one a little bit different, didn't I? So like if I looked here, you'll notice this is the formula, right? I already said it's y to the fifth. So if it's y to the fifth, that means y is to the r power. So therefore, r is what? R is 5. Does that make sense? So it's a little different on this one as what it says in the formula sheet.
Okay.
So I would say throw this down there, and then you're going to match these two up with, what would be there. Cool. Again, I think that's probably one of the tougher ones, to be honest. I agree. Just plugging it in though. Once you understand what goes in for what, and then just do each step. Remember, don't multiply them all together. You'll be fine. Cool. All right. Do we want to just keep rolling on unit 4? Cool. Okay. Number 4. Are y'all pretty good on number 4? No.
Do you plug in 5 for
So
5 for A?
Well,
yes.
It's the first 5.
Yeah. So if it's the first 5, literally, what do you plug in for A? If I find
You
the
have to be
first 5
like
terms.
1 and 2, 3, 4, 5. Like
Oh,
all the way through.
it's one of them. Okay.
Yeah. Just plug 1 in, plug 2 in, plug 3 in, plug 4 in, plug 5 in. Cool.
Okay.
If that's a little tough, I just say just take it step by step, right? So when I plug it in, like if I was gonna do number 1, okay, good morning. If I was gonna do let's say 1, make sure I say A1 equals -1 to the first times 2 times 1 plus 9, right? So -1 to the first is -1, right? I know this is very monotonous. 2 times 1 is 2, plus 9 is 11. 11 times -1 is -11. That's the first term, right? Then go plug 2 in, right? -1 squared, right? Times 2 plus 9, right? Very monotonous, but just note that it's going to be a little different. There's not going to be a real pattern to this. There might, but it won't. There may not be. So just be very careful on it when you find the first, second, third, fourth, and fifth term. Okay?
So you just plug each number into the equation that's given here,
Correct.
and you plug it in for both ends.
Correct. It's exactly right.
Yeah.
Good. Good. Yep. So wherever n is, we plug 1 in, 2 in, 3 in, 4 in, and 5.
Okay.
Get it out. There's a way to do it on your calculator.
Yeah, I was wondering if there's
There is a faster way. If I was to go to do that, you could go to y equals, plug the equation in. So it would be like -1. You literally just what it says, except x goes in for n, right? Because there's no n there. And then just 2x plus 9. Do you see how it's basically it's the same thing? And after I do that, you're not going to go to graph. You're going to go to this table over here, okay? So when you go to table, go to second table. And there you are. So you got 1, 2, 3, 4, and 5. So you literally label those there. -11, 13, -15, 17, -19. There's actually a pattern there, but you can just throw them down on that.
Yeah.
That way, that's a little easier.
yes, that will save
Just
time.
know both, just in case, because sometimes it might be a calculator or a non-calculator one there. Scotty, back in. Look at this crew. All y'all.
Third period.
Y'all dominated. I'm telling you. Domination.
You only have one video.
Wait, how did you find? How did you know the calculator again?
To get the table, you're saying? Yeah. You know how to go into y equals, right? Just plug it in.
Okay.
Go to second graph. And you see the table there?
Oh,
You're going to go actually to the table by going second graph to get to that blue area.
Oh, that's it.
Exactly. If it doesn't, hopefully your calculator does have this. I would just double check to make sure. Hopefully it starts at 1 and goes forward. If it does not, you can always go to second window and you see where your table start is.
Yeah.
You could start it at 0 and just go by ones, like 0, 1, 2, 3, 4, 5.
Okay.
Can you go back to y equals? What did you?
Just whatever was up here on number 4, the exact equation on that. Cool. Scott, we're on unit 4 here. So we're just going through a lot of this. We're on going to be in number 5 here in a second. But yeah, if you have any questions, we're just going to go through some of those. All right, thoughts?
That was fun.
Not crazy yet? Okay. I was just showing them too, just so y'all are aware, because I know y'all came in. Here's the new formula sheet, and I have the foci stuff that we talked about yesterday. Cool. But this right here would be what I would just go to just to double check. Make sure you're familiar with the formula sheet, because I would hate for you to like spend your time trying to look for a formula. Just kind of have a, not memorized, but just an idea what would be there. All right, 5, 6, or 7. What are y'all thinking?
So for 5, you just literally put like expand it 3 times, then multiply.
You
Can we
could.
go over expanding?
You could.
Can I just do that? Is that okay?
I would say just be careful. The reason why, if it was to the 4th here, that would make it much harder. Cool.
Right. But you can just like, you can put it in like 2 pairs and like multiply the first pair together and then multiply the second pair and then multiply those together.
You absolutely could. I would say you could.
How would you?
It would just take longer. Cool.
Okay.
There's a Pascal's triangle that's on there. Okay. That basically y'all just grown. Yeah. All right. So here's the thing. Whatever power it is, whatever power it's to, you're gonna have one more term than you have power. Cool.
Because like 1 starts with 0, so you're gonna have 4.
Correct.
Okay.
So if it's, we'll just keep it to the 3rd right now, because if it was to the 4th, you would just do the same thing, but the lower row there. Because it's to the 3rd, we're gonna have 4 terms.
Okay.
So then that's when we're gonna go 1, and just give yourself a ton of space. 1, 3, 3, 1. Okay. What happens with the x power?
You start with x to the 3rd,
Good.
and then x squared,
X squared. And
then x.
what happens with y?
Start with y to the 3rd.
Y squared, right? And y. All right. Y'all good?
So.
Yeah.
Jacob? Tell you what. Look at y'all.
What's up?
Man, y'all have,
Showing out.
you have shown out.
That means where
There would only be like 1 of these on the test, right?
Well, remember that this is an exam, so I don't have room to, you know what I'm saying?
Right.
So there's just going to be one of probably each of these.
Right.
Not, and some of them may not show up. But
So if I spend like 10 minutes on this one, probably it's not really going to be
if I was you, I would skip this one. Save it for the last thing, and that way you could always use this as the last one. Because I agree, because it takes long, and it's very like it's very detailed, you know.
Okay.
So I would say this one to last if I were you. Just takes a little bit.
So there's a 2 in front of the x.
Correct.
So what do we do with that?
So once I've set up what's here in yellow, the part that I'm going to do now is now in blue. I'm going to come back to this where 2x now becomes like goes in for x here, and negative y goes in for y. So what I like to do is give myself room, because then I can say it's 1 times 2x to the 3rd, right? And that would be number 1. The second one is 3 times 2x to the 2nd,
To the
and
next
y. What's up, Alex? Awesome.
So happy, all of us. Inadequate students.
All of us struggling
together.
Look at y'all. I was actually, I was telling everyone that I'm impressed. I was telling other teachers, I was like, I guarantee you don't have as many seniors as I have had in my Precal 12.
My college actually cares about.
Good.
I know.
Important, right? So the third one, right? We just simply we're just going step by step, where we'll plug 3 times 2x times negative y to the 2nd, right? And again, if you want to, just divide it up so that you've got like separate ones going, right? That helps me. And then my last one, we plug y, negative y, in for y, and we make it to the 3rd.
Are you?
I am, yes ma'am. Yes ma'am.
So then now we distribute the coefficients and stuff to each.
Correct. So we want to make sure the power. I've seen a lot of things on the last test that people messed up on. They would get here and like, and by the way, you get half credit because you've done the setup, you've done it, but now you've got to execute to get the full credit, right? So like here, make sure you do the power first. So this would be 2 to the 3rd, which would be
Hang on.
Hold up. Y'all don't know what 2 to the third is?
8.
8, yes.
Hold on.
We're smart. We're not that smart.
And
We've
then
already had some summer in this coach.
It's
starting to lose. So.
oh my. And then what would x be to? X to the third. You just got to make sure you've got it. And I would circle it, letting myself know that that part is done for my first one. Okay. Now the next one, this is where we start messing up, I think.
Yeah, because I always get confused on which one to distribute first. So do it just exponent first and then do the coefficient. Like,
Correct. So we got to do exponents first. So 2 squared would be 4, and then x squared would be just x squared, right? So then you get something that looks like this, right? Which looks a little weird, but one of the things that a lot of people did was they would take the 3 and distribute it to both. But that doesn't happen because even though this is a negative y, each of these 3 are being multiplied together. So all you do is just say 3 times 4 is 12, x squared and negative y.
That's all.
Cool. So what is the negative? Just throw it in the front, right?
Wait,
And
so
x squared y.
I wasn't here for the beginning of this. You just set it up as like 1x cubed. Wait, what?
So this is 2x minus y to the third, right?
Yeah.
So what we do is on Pascal's triangle, which you'll get, all you'll go to the
Oh,
row
the
that's 1 greater.
4th row, and then you just write it as 1. Oh, and then you like okay, good. All right.
So the yellow one is what I put
Yeah, I remember.
every time, and then I substitute 2x in for x and negative y in for y.
Okay.
And I was just saying, just the big thing is that I would save this one for last because it's very detail oriented and it's easy to make a mistake. So put it out there, give yourself a lot of room and take your time through it. What about the third one?
so do negative y squared,
Which would be
just
So,
y,
y squared. Good.
y squared, and then it's going to be negative 6x. Because I took the negative from y and put it in the front, right?
I would say make sure you do the squared first
Okay.
because negative y squared would be a
Oh, it's
positive.
just positive.
And so this would be, what would this turn into?
6x.
Y squared. Here's the thing too, here's a hint. If you have a negative value, notice it's a positive, negative, positive. You'd expect this one to be a
Wait a minute.
negative.
Why?
Okay.
Why is the y
Yeah.
equals squared if we made it positive? Or did
Why is the y squared what again? I'm sorry.
because like it was negative y squared and then we turned it into positive y because we did y squared.
It's
And
like
then the squared stayed.
negative 1 squared, and then y squared. Like for parentheses.
Does that make sense?
Yeah.
It's a good question. Good question. And then finally, negative y to the third would be what? Kendall, what would that be?
Negative. It would just be negative y.
Yeah, negative y to the
Third. Oh, just the same.
We should have new balls.
Yeah.
Okay.
Yes, I did.
Because this is disgusting.
Yeah, they were disgusting. Hello.
Oompst is here. Oompst is here. Oompst man is here.
How's it going? What is up, Chris?
Chris,
Oh,
come
man.
save me.
Try to read on that sheet.
I immediately watched her. I was like,
Yeah,
what
sure.
are you doing?
They just want to
Down.
No, it's time to stay out. Yeah.
If anybody can hear me right now.
Yeah.
Why did it turn around like that?
And then-
Like,
the security guard. What are you doing? Yeah, she's been. She's like,
I replied.
Can I take this?
Look at this point. They like.
I read it up once. Same. I will not be like studying for fun. Actually, no.
Not everybody.
Especially for how we're like, I think I can get by with a 3.
Yeah.
That was
I just haven't remember like that phrase.
I'm not 100% sure how it works.
Oh,
Good section. Regardless,
Oh, no.
you want to do 12 o'clock?
Yo, wait, anyone in environmental?
yes.
Meeker still hasn't put in our test grades, and we have exams
Go
tomorrow.
talk to machine.
And I'm this close to
Go
exams.
talk to machine.
Yeah.
What do you have in there, teacher?
I have 92 points, and
Oh shoot.
Wait, that's actually, I would round you up.
I can.
Hey guys,
I don't have any power, but I can have people.
Go like
Is
right
she your
after
teacher?
this. Yeah.
but
Oh.
shoot me out.
No, because the only thing is like I think I got 100 on that last test, and that'll give me
Yeah.
an exam grade.
You guys probably in there too, just be like, yo, like, hello.
No, I just want to know. Like, I'm not gonna study no matter what. But like, I want to know.
Also,
Do it.
Is
Hey,
your
Chris.
AP like grade final?
All right, are we good?
Coach, I have an exam tomorrow. Coach, I have an exam tomorrow.
Again?
I have an exam tomorrow, and my teacher hasn't put in our most recent test grade, so I don't know if I can exempt or not. It's really weird. I'm in a
Oh,
weird
man.
state right now.
That is weird.
Meeker, if
So
you're
do you
doing
study?
this, Jake,
Nope.
you're ready
Nope.
to have some beef with you.
Oh man.
I'm not studying.
the exam?
Same with Bible.
Yeah,
Oh,
same
Kenny T's
tomorrow's
not ready. How
8:10.
bad I'm about to fail this
Where,
exam.
though?
I'm getting
18.
2 on
Here,
Bible.
here.
I'm gonna go out of my way to learn all the answers so I can get.
Where did I? I've not texted that out, have I?
No.
So you're gonna
I've got it in
I'm gonna
mind.
study so I can fail.
If you are watching this right now,
that is
The-
not a good tactic.
the exam on Wednesday, tomorrow, is.
That's gonna make it fun.
Oh, here we go. It is in the
I'm like, stop.
PAC 102, 104, and 105. Is that over in the?
That's downstairs.
PAC.
And then
Yeah, that's
PAC is
about
like the
3
Bible
nautical
class.
miles.
Just
I'll go by and ask the front office because I won't be taking it.
Very far away.
Yeah, I know that conflict.
If you've got a conflict, I think they've got your exam over there, which I think you're doing on Friday. All right, or is it
Oh.
No, I'm just taking it at like the 1 p.m. time tomorrow.
Yeah, there's like the conflict tomorrow. The conflict's tomorrow.
I can't push it off.
Cool. What's up, Nicole?
Good morning.
Oh, can we do?
Uh,
Can we do 6 and 7? And 4?
Like it was
Oh,
really
yeah.
bad.
Oh
So
yeah.
I'm driving.
That was like my worst lesson.
There's 2 lanes. One going that way, one this way.
What was that?
You
So
know, I
took my
changed
tutor
the
test.
lane.
Yeah,
I
yeah.
was like, there's a car going my direction, like in my lane. So I had to get over in my lane. Yeah, feel free to grab her. She got her.
I only had like 3
That
days.
was terrible.
It's been tough.
All right, Unit 4. Let's continue. Hence 4. All right, y'all are rocking, by the way.
Third period wins.
Man.
If you're in third
Second
period and you're not here,
With a
Mary
sprinkle of,
Thomas,
With a sprinkle of
Oh,
Cameron.
man, well, call people out on
Cameron
my name.
Brasher,
Nathaniel Ritchie.
Nate Ritchie.
Whoa,
Anyone else?
this is gonna be.
I saw Nate last night. I asked him where he was. He said he wasn't going to
Oh, there you go.
I guess
You
it's
let it
mine.
carry. Yeah, I just couldn't say it went.
He gave up.
Okay, so let's do this. We're gonna continue on Unit 4. If you are just came in on Unit 4, I've done numbers 1 through 5. So if you need more individualized time, hopefully by the end of today, I'll be able to go through that together. But I'd like to on the podcast continue with a lot of this stuff that we're doing right now.
If you
Okay.
just like literally go through them all, that'd be.
Cool. So continue on 6.
Wait, I have a question
Please.
before you.
So,
For the 12 one, 12x squared y, because it was just negative y, do you have to distribute that negative to the whole thing?
yeah, good question. Because this is acting as one distributing, I want to be careful on that word because that normally denotes that it goes to one and then the other.
Okay.
But really, we mean that we're just going to multiply all these together.
Okay.
So since we have one negative, we shoot it to the front, and then we multiply 3 times 4 to get 12, and then we just keep the x squared y.
Okay, and then also, are these all separate answers? Like, how would you like these answers? Because you circled them all separately.
Yeah, I did it just to hopefully help us to just say, okay, we've got 1, 2, 3, and 4, but really it needs to be all together. To say 8x to the third minus 12x squared y plus 6x y squared minus y to the third.
Okay.
Just so
So
you
you
can
don't multiply.
Yeah, that's the answer.
That would be your answer.
Okay.
Just literally all the way out. Okay.
Can you just leave it like that?
Like how I have it there?
Yeah.
I probably would be okay with that. Just know the reason why I divvy them up is because I think that for at least y'all, I saw on the last test that with this, that people put them all together and they were mixing them all up. So just divide them up to where it's literally like each a separate little mini problem and then combine them all at the end and you're good.
Combine them as like a,
Like
it's like 8x minus 12x
Yeah, yeah.
squared y plus 6x. Okay.
Exactly right. Good. Good.
Fancy. That's what you got there.
Okay. Let's continue because these next two are probably ones that you love me for. I know this. These ones are the ones that you just absolutely
The worst ever.
love here. Okay. So anytime that it says find the nth term of the sequence or write a rule or something along those lines, I would first start by saying, is it adding by common difference or am I multiplying by common ratio? First thing, absolutely first thing. So as I look at this from -3 to 3/2 to -3/4 to 3/8 to -3/16, am I adding by something that's in common?
You're
No.
multiplying by
Oh, right.
-1/2.
Perfect. I am multiplying, right, by 1 to the next. And as I notice that if it's a negative, positive, that's something that in your mind you could say, okay, I can't, if I'm adding or subtracting, it's not going to go back and forth, right? But if I multiply by a negative number, it could possibly go back and forth, right? So if I look at -3 times what is 3/2?
-1/2. Okay. Oh yeah.
-1/2, right? If you can't really see that, is the top changing? No, right? So just put a 1 there. Is the bottom changing? Well, this has an imaginary 1 on it, right? So 1, 2, 4, 8, 16. What's happening? It's multiplying by 2. Good each time, right? And because of the fact that it goes negative, positive, negative, that means my ratio is really not just 1/2, but -1/2. Good. So my ratio is -1/2. Now that's a huge deal because now you just made a problem like 10 times easier. Because now since we have a common ratio, we can assume that this is a what type of sequence? Geometric. Okay. Which you'll have these formulas. You'll have those there. The geometric equation is a sub n equals a1 times r to the n minus 1. Right. Well, what is a1 in that sequence?
3.
Yeah, just -3, right?
Yeah.
But you're right. So we have a sub n equals -3 times, what's the ratio? -1/2 to the n minus 1 power. There you go.
That's it.
all.
That's it.
Wow.
Can you explain why you're saying -1?
Why it's n minus 1?
Oh, I didn't
That's
see what
formulas.
that's talking about.
Yes.
Scooter.
Scooter.
Where's
Yeah.
the 3 from?
What a name.
Yeah. Say
This
again.
guy never fits it up.
The -3?
Make your
Good
face
question. It's
scooter.
just the first term in my
Oh.
sequence. That would be a1 in the cool. But that's a one way if and only I can do this when what happens? When it's geometric, right? I'm multiplying by a common number. Ratio we call it. Right? All right, now look at number 7. Am I adding by a common number? Do I have a common difference we call it?
No.
No, right? It's not consistent. Am I multiplying by a common number? No. Notice on the bottom, 1, 4, 9, 16. That's not multiplied by anything in common. So these are the ones from the pit of you know where. Okay?
E.G. double high.
So we have a sub n equals. Now these are ones where we got to tweak a little bit. Okay? Question. Does the top change?
No.
Now.
No, so let's just write 3 on the top, right? Okay. 3 goes on the top. Now,
Wait.
Why'd you write 3 there? But
Yeah,
the
well,
first time it didn't change.
Oh.
okay, so for this one,
Yeah.
yeah, I hear what you're saying. That is possible that I could do that. Meaning there are, let me backtrack. There are multiple ways I could write this. What I did was I tried to simplify it by saying, again, what are the two, if I see one like this, 2 questions, right? Is there something I'm adding that's in common? Common difference? No. Okay, so rule that out. It's not arithmetic because we're not adding by something in common. Second question, do I have something that I'm multiplying by each time? On the top part, the answer was yes, right?
So you
And
can-
you all told me that that number was -1/2 each time.
So you can write it like that for geometric.
Yes, absolutely. Absolutely. Is there another way you could write it? Yes.
Could you write it?
You're multiplying by this, like by 1 on the top on this one too. Why would you?
Correct. I am. But am I multiplying by something that's in common on the bottom? No, I'm not, right? So is this complete sequence a geometric sequence? No. Whereas this one was, right? That's why I went and did it the easier way, because you got the formula. It makes it easier. Just plug it in. This is much different. I'm not multiplying by something in common. So for this one, I can't use like a formula like we just did. So this is why this one's much more difficult, because I've got to actually look and see what is happening from one term to the next, and I've got to create the equation or the rule that's there. Whereas this one, since it was geometric, I'm going straight with the geometric equation, right? Yeah. Because I am multiplying by a common number. So the first thing I would do, am I adding by something that's in common? No. Everything's out. Am I multiplying? Yes. So this was geometric. I asked the same question, right? Is it a common number that I'm adding? No. Or subtracting? No. Am I multiplying or dividing by a common number? No. So that's why this one is a little different. I can't plug it into one of the geometric arithmetic equations, right?
Oh, so it's not either.
It's not either. So I've got to come up with it myself. So that's why on this one, Parker, I'm approaching it just a little bit different by saying, is the top changing? No, right? So in my rule, if this top isn't changing, I'm just going to simply put a 3 on top like you see here. Now, the bottom, is that changing?
Yeah.
Yes. So this is where we've got to see and really just kind of identify 1, 4, 9, 16, and 25.
You're adding an odd number.
Your square.
Every other odd.
Okay, I like that. So I'm adding, what's it, 3, and then
7.
5, 7, 9. So that's still not adding by a common number, right?
Do you like
Makes sense.
3
Square.
plus 2? Or like do you have to add like a plus at the end? Like you've done it before. You've done it before where you do like multiply it times something, then you like add it.
I have n squared written down, but that doesn't make sense.
Okay, so, and I'm hearing what both of y'all are saying on this. There's an easier way than how we've approached it. And Parker, you said it. Now, you may not understand why it's the case. Scott. Scott didn't say that, did he?
Yes,
He did not.
I have it written down when he said it, so.
I heard you. I just wanted to hear what they were saying because you were right. You were right the whole time. Scott, can you explain to us like why it would be maybe n squared?
Because you plug in like 2 squared it'd be 4, then 3 squared 9, then so on and so forth.
Yeah, so take the number 1, square it. You get 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared.
I'm not gonna see that though. Like I know.
Why would I
Like
do that?
plus 3 plus 4 plus 9.
Yeah. Again, what I would say is when you get to them,
Right, it is a square
ask
root.
the question. Square root, I like that.
Oh,
I like that.
See, this is a square root on the bottom. You don't want to do that.
I like
So
that.
the
Did y'all hear
bottom
that?
is just
See, this is the square root on the bottom, then you can pull that rule.
That's a rule.
that one's gonna get me.
Oh, yeah.
Okay.
That one's gonna.
Now that I've seen it, it won't. No, probably still won't. That's
Here's the thing is, and I'll tell you all this too. Perfection's not the goal, right?
Passing is the
Passing.
goal. Passing is the goal.
That-
I want to get a bucket.
y'all are gonna do better than passing.
Gotta
It's
get
my
at least
my
a 4.
fault.
I want to
Oh,
get a
really?
bucket. Wait, are you one of those teachers who makes your review like guides harder than the actual test so that we're really prepared? Please say.
What if I would say that the pattern of what I've normally done of the concepts of what you need to know the concepts over. If you memorize problems, like if you memorize, oh, if I see 3 over 1, 3 over 4, 3 over 9, 3 over 16, oh, that's going to be 3 over n squared. I'm going to memorize that. You're not going to do that, okay? However, I mean, right? But look, if you go through the process like we were talking about on the top one of the fact that this right here, trust the process. Right here, if you notice that like, okay, why did I get this?
No,
Well,
Right, but
You know?
I'm saying like numbers wise, are you making this harder so that we'll be better prepared, or is this pretty much a valid like?
I'd say it's if you understand the concept, it should be fun. It's fun. So,
You said 2 and 4.
Parker, here's a
Yeah.
question for you on this one. Does it make sense why there's 3 up here?
Yes.
On the bottom, I not get why y'all are saying this. I know it's a little different. I like what Jacob said. Some of you may have heard it. Some of you may not have heard that there. Look and see if you can take the square root of each of these numbers, right? And you can get something that's even. Probably there's going to be something that's like n squared, right? And here's the deal. If you throw something out there, right? Like I know Kendall was throwing out something and Parker was as well. Try it. Throw it out there. And then test it by testing those numbers as you get plugged in, okay? Chris?
Could say
You
how
want to join the party?
How long do we have
What's
for
up,
this
Rita?
exam? Whoa.
Say again?
How long do we have for this exam?
An hour and a half. We have an hour and a half.
How many questions?
30. Pretty good.
30? Yeah, it's pretty good.
I mean, normally exams are much longer.
120.
No. An hour and a half one is like not long
Wait,
enough.
but like we have tests in class.
Oh,
for,
not
like,
long
12
enough.
questions. They take an hour and a half.
Yeah, like a block test.
Oh, that's right.
It's like a block.
I didn't think
I've not from other years. I've not had a major issue with that.
Okay.
You know what I mean? Because remember too when you come in, right? When you come in, traditionally, what do we do for the first 20 minutes? Review, go through it, right? This is a little different.
Bro.
So I would say I think we'll be fine on that.
You know how like on some tests, you have some like very similar questions on the test?
Mhm.
I'm just saying, number 7 is like the exact same thing. I would not be mad
You won't be mad?
at all.
I would say 2 things. Check out the first one that I did yesterday. It's on the podcast. It's like the very first one. Check that out. And then number 2, I would say my goal on this is for you to understand and know the concepts that are from this. Like I'm narrowing it down for you. The review sheet is not, it really wouldn't test your knowledge if I did the exact problems. But if you understand why we got to where we got to, you'll be fine. You really will be fine.
So will we have like a question that's like we would have to know like that's square?
Yeah, like,
I would say, yeah, that would be something just to see, see there. You know what I'm saying?
Hey, Coach Jay.
Is there any significance with the highlighted questions?
The highlighted ones,
Make sure you look at
don't just do the highlighted ones.
Okay.
But I will say that the highlighted ones are really, really good to know.
I'll check those
Can we
out.
look on it? Never mind, we don't have it
Gotcha. Is that what we're doing now for you?
Yeah.
Gotcha. Okay. Number 7, we're done with. Are y'all feeling okay?
Wait, we are?
Oh,
that's what we do. Okay.
I think. Are there any other? Oh, we have 8, 9 here.
Those are the last 2, I think.
The last 2.
Oh, no, we have 10. 8, 9 is bad.
Number 10. I forget number 10.
It's like
Um,
on the second.
Yeah, we'll get to that one too. 8, find the sum of the infinite geometric series. Okay, stop right there. You see that? Put the formula down, right? So infinite geometric series, put down that formula. You'll have those there. And if you are, here's what I would say to that. This is the formula sheet that I did for those of you who came in late. I did put down the foci formulas for you from yesterday. But you should check those out. But just kind of keep an eye on where these terms are. To Jacob's point and to y'all's point, and Parker, what she was saying, it would take you, look over the formula sheet and know where things are. Don't memorize it, but it will at least help you with timing to know, where the series formulas are. And that way you could just take the sum of the series that's there.
So is that online?
It is online. Yes, ma'am. Okay, so as we look at this, we have a infinite geometric series. So sum of the to infinity is equal to a1 over 1 minus r. Straight from the formula sheet right there. Okay. What's a1?
Negative 6.
Negative 6, good. And probably the tougher part of this question is what r is. What am I multiplying by each time?
Well, it's geometric,
Now-
so it's going to be like
5, 6,
common
5 or
difference.
6.
And it's going to be a negative number going back.
Negative 5 or 6.
Correct. I like it. Good. Both of you were exactly right. And what I love about what they said too, it's hard to see the ratio from -6 to 5. Some of you could maybe do it, but if that's a struggle for you, you know that the ratio is consistent, right? Because I've already said it's geometric. So question, from 25 to 125, what'd you multiply by? 5, right? Good. And what about 6 to 36? 6, good. And why is the ratio then -5/6? Good. So then that's where we, on the ratio, on the R side, put -5/6 in for R.
That's like,
And then we're just simplifying.
Yeah, I understand how you got from 5 to -25 over 6, but I do not know how you got from -6 to 5. I guess it doesn't matter, but.
It's a good question. So yeah, no, I completely get it. So take -6 just to double check yourself, and just say -6 times -5/6. What's -6 times 6?
6.
30.
Wait, no.
No, you were right. I messed up. -6 goes into 6.
6.
Oh, so they can't.
That's right. So -1 times -5 is 5.
Wait, no.
Show me how you got it.
-30 divided
R
by 6.
Say that again.
-30
It's just the
divided
rate.
by 6.
Which is good. Which would be?
Oh, yeah, never mind.
Wait,
Yeah,
I'm so
yeah, how you-
No, I'm so.
Alright, can we backtrack like?
Wait, no,
3 steps?
-30 divided by 6
Yes.
would be -5, but it's +5.
No, but it's -6 times -5 should be +30 divided by 6, which is 5. If you're doing it that way. Like -6 over
Oh,
1.
it'd be 30 divided by 6, which is 5.
Yeah.
Good.
No.
Chris? Scott?
Alright,
You get how we got A1?
I'm just confused with the series, how it goes from -6 to +5 to -25 over 6.
How do I know it's geometric?
Because it says
Perfect.
On the board.
So we have a common ratio, correct? Okay.
Did you? It looked like you skipped -6.
Yeah, look, these two I did skip
Okay.
because it's hard to see the ratio.
Yeah, okay, I'm seeing what
You see what I'm saying? So look at the fractions. I find it easier because you know it's consistent, right? You know that the ratio is going to be negative because it goes back and forth. And you know that from 25 to 125 we multiply by what? To get from here to here? 5. And what about from 6 to 36? 6, good. So that's why it would be 5 over 6.
I get that. So why is it a negative?
Just because it goes from, like it flips sides.
How do you
Wait,
say
so
answer
is the answer 5?
No.
No.
Yeah, it's really like that's not really confusing.
I haven't done that yet.
Okay, yeah,
We're on the same page now.
This is good. This is good.
Wait.
My answer's not 5.
Okay.
No, that's
We don't like it?
That's how you get to
I
negative.
understand, I don't like
What do you not like about it?
Everything.
you can't change it.
I'm not gonna, like, this is all respect to your job. Oh my god, I was like, when are we gonna use the sum of infinite?
Never.
Like, I understand that
Whoa.
I need to know it for now, and there's a lot of like times when math is so useful. But for this specific question, why do I need to?
Michaela's getting a little. When you become a math teacher someday. And no, I get it. And for legitimately, what motivates me in teaching y'all is for the college placement.
Math placement exam, yep. When do we take that? Do we take that like here, or do we have to?
You'll go to your school. So Georgia's and Georgia State's and everyone's.
I have to take one.
My major, it doesn't require that much math, so I can't take it. So I can't take it.
I got one Felicia. How much I
Yeah,
They said that I can't leave my major.
Okay.
But I'm still motivated for right now.
But like, I gotta see if I gotta fly.
All I have to do is know how to fly a plane for my degree.
Would you need to do what?
All I need to do is know how to fly a plane.
Hey, what the math placement exam
We're
is?
making big moves.
I did like,
Wait, what?
Alex,
Yeah.
do you pay attention?
What?
Alex, you
Wait,
suck.
what is
No. Hey, those that were in my class, how much did I mention?
Like every single day.
You just
Alex is coming to me.
What is it?
You had a whole like learning
It's important. Oh, Alex, it's you'll go when you go to school, okay? You're going to take the college. You remember this?
Yeah,
He doesn't remember that. He should-
I did tell you about it.
Yeah, I know you don't remember it.
I still don't remember.
All right, next question. Is it
Yeah.
required?
I still don't.
Is it required? No, but
it's
you
not
want to
required.
take it.
Some schools require it.
Like,
Mine
you
is.
want to take it because it can't hurt you.
If you don't take it, then
It
you
hurt
will
my
have to
heart.
take every single math class before the math class is actually due.
All right, number 9.
Let's do this. Okay,
Yeah, I
we're,
took, like,
we're not
college
even done with
algebra.
this one.
People who like
I don't
didn't
think.
get that.
I don't think yet.
36 over 11.
Oh!
Oh,
When we add this together, right? We make that positive. We have 1 plus 5 over 6, right? And we want to get common denominators here. Want to get the CD there.
Oh my gosh.
So what does 1 turn into?
36.
6 over 6, yeah.
This is an example of how
Which would be?
It's a house of cards.
So negative 6 over 1,
5.
right?
Negative 6 over,
Oh, whoa, sorry, my fault.
I think that would be
11.
11 over 6, right? So how do I simplify that?
You flip it and then multiply. Flip. Oh my God.
Let's do
Negative
good.
36 over 11.
Nice, that's exactly right. Good, Jacob. So negative 6 times 6 is negative 36. Divide that by 11. So we would just say it's negative 36.
You on the road this time. You're a comedian now?
We've been
I'm in a
included
really cool house of cards.
Right? Negative 6 times 6 over 11.
Wait, if you have to do negative reciprocal or reciprocal?
I'm just gonna have to mess this
I
one.
wouldn't do it.
Yeah.
This one? Really?
Is this your card?
It's a little.
What do you mean?
Like, I'm just not gonna answer.
Bamboozled.
Don't do that.
That's my card.
No, don't do that. So this right here, do you get that you got here?
Yeah.
Do you get that this is A1?
That's
Do you get that this is R?
I'm gonna have a gambling addiction.
No.
Sort
So
of betting ring over
from these two, right? 25 times what is 125? 5, good. And 6 times what is 36?
So why do you disregard this?
They don't
Negative
sound
6
like
plus 5?
It's not that I'm disregarding it. It's just easier because I know it's the same ratio at the top. You're still multiplying by the same numbers.
Yeah.
But if you look at negative 6 and 5, it makes it much harder to see what that ratio is. However, if I look at a fraction like I did on the outside, it makes it much easier to say, what's being multiplied on the top? 5. What about the bottom? 6. And then I just make it negative because it goes back and forth between positive and negative. And then I can just take that and plug it into R.
Okay, and then with so A1 is negative 6, and then the 1 minus R, why did you put 6 over 6 for the 1?
It was 1 minus negative 5, 6 here.
Yeah.
So I make that positive. In order to add them, I need common denominators, right?
Oh, okay.
So that's where I made it 6 over 6. And then added to get 11 over 6
So
there.
what's the final thing? It's
Negative 36 over
Wait,
11.
but then
That doesn't seem that bad.
11 over 6. Then how'd you get negative 36 over 11?
Oh, good question. So I flip this to the top. And so I multiply by the reciprocal. So negative 6 times 6 over 11.
Despite the existential crisis that everything we've learned in school is pointless, this actually is not hard.
Good. I will take that as a compliment.
That's a lot.
That's good.
That was big.
All
I have
Good.
a question.
Yeah.
It's kind of not really related, but related at the same time.
Oh no.
Oh, no.
Top physics duty.
You want to diss my job again?
How far
Why
away?
what I do is pointless?
Oh my
How far away is
Because I already said you.
Say yes.
So, you know how you do partial credit? I would assume college does not do partial credit, right?
No.
Oh.
In fact, if we were going by college, they have 4 grades, and that's it. No homeworks or anything. No homework grades at all. Which seems good because you have no homework in college.
Oh.
That's not
You
good.
need math homework.
Yeah, math is like the only.
You, but that's on you. That's on you. So it would be basically, they'll say, hey, you got to test in 3 weeks, 4 weeks. Good luck. Your job is to prepare yourself for it.
That's not funny.
There's gonna be some L's.
That's terrible.
I love college. I did.
I
If
can't.
you are
I'm sure I'm
a,
going to
if
as
you
well.
are a
It's better.
self-motivator, you will do very, very well. College is more about grit than it has anything to do with ability. I mean, it does, but if you're, what I call gritty, and I mean that in a good way.
This guy's been coming in, it's like he's waking up to go.
That's why what I see,
That's
there's
some
sometimes
early
people
wake up.
I'll say,
Coming in.
you'll do really well in college. And they'll be like, why do you say that? And it's because of.
This guy's like, oh, dude, I gotta stand up for it.
All right, can we do number 9?
You're taking
Okay,
out.
9, here we go. Alright, hey, number 9, I'm gonna try to simplify this as much as possible. Recursive means that I'm continually plugging in a number and just basically getting out whatever the formula says. So when we see something that's a sub k plus 1, that is a fancy way of saying that this will be the next term. Cool? So if I see a sub k plus 5 halves, or 2.5, which is the same decimal, right? Is everyone good with that? 2.5. Really what we're saying is if the first term is 15, and I plug 15 in for a sub k, 15 plus 2.5 is what? 17.5. Good. So that means 17.5 is this next term.
Oh, you keep going. All right.
And then you just do 17.5 plus 2.5 to get 20. 20 plus 2.5 gets me?
22.5.
There you are. And 22.5 plus 2.5 is?
25.
So
How
in
many
this
do you want
case,
in this
though,
situation? Because how far you want us to go?
whoa, wait.
5.
Oh, it just says find the nth term. So if I said find the first 5 terms, you would have had it, right?
But if you want 15, so you just do 17.5.
Oh,
Or the fif-
wait.
In this one, though, they want you to create an equation for the nth term. Okay? So this is like the rule that we were talking about, right? Right over here. You're the ones that you loved, okay? But it's not too bad because when you go here, look at this one. Is there anything that I'm adding, same questions, anything that I'm adding to get to the next term? 2.5. So if I'm adding by 2.5, it is my kind of, but now am I arithmetic or geometric? Arithmetic, right? So we're literally just going to plug down the equation that's on your formula sheet. So a sub n equals a1 plus n minus 1 times d. And what is a1 here?
15.
15, good. And what is the d?
2.5.
2.5, good. And so technically, really, this could be your equation, and you'd be fine. It'd probably be better to like distribute 2.5 and then like subtract it, right? We'll do that, but probably would take either. So we got 2.5 n minus 2.5 when we distribute, and then we just simply combine together to get a sub n equals what? Yeah, Kendra.
Oh,
go ahead.
no, I don't have the answer.
Sorry.
I have a
Go ahead.
question. How do you know it's arithmetic and not geometric?
Yeah, good question. Because we're adding by a common number, right? We call it a common difference.
Oh, because it says plus 5.
Correct.
So it's a sub n equals 7.5 n plus 12.5.
What'd you get here again?
Wait.
12.5?
That's wrong.
No, you're good. 12.5 plus 2.5 n? Is that what you got there?
So first, you plug a number into the equation to get a1.
Mm-hmm. Well, A1 was given, right?
Oh, wait,
I actually,
I see.
Kendall, to be honest, this was my fault. I technically didn't even have to do this.
Okay.
If I said find the first 5 terms, I could have. Really, what is my common difference? What am I adding? 2.5, right? Because it gives it to us.
So that's what it is.
And A1 is 15, right? And all I have to do that, if I see that it's a common difference, and that A1, the first term is 15, this is the equation we use for arithmetic. Plug it in and go.
So D is the same thing as R in geometric.
Correct. Exactly.
So, wait. So you have n minus 1 at 15 plus n minus 1 times 2.5 plus n. And then you distribute it, and it's 15 plus 2.5 n minus 2.5?
Correct.
Wait, what is happening?
This one here.
Yeah.
Did you see how we were in an arithmetic world? Because we were
Yeah.
adding by something, right?
Yeah.
All I did was plug it into this equation, which you'll have. And then I plugged in A1, which is 15. And D, I plugged in 2.5.
Because that's the common.
Correct.
So
And then
that's
I
just, so when you want the nth term of the sequence, you just plug it into that.
That's it.
Okay.
That one's not crazy, right? Not crazy. Just identifying what's going on, and then that fact that it's arithmetic kind of helps us there. I think, yeah, there it is. There's 10.
Is it just like 2.5, 10?
Oh.
For
2.5. Say that one more time. I'm sorry.
2.5. No, for number 10.
Oh, 2 point. Yes,
2.5, 5,
That was
10,
terrible.
20, 40.
that's correct. That's correct.
Because it's just the one half.
Yeah, so I like this. How many terms am I finding? 5, right? So in this example, literally put 5 different spaces for 5 terms, right? What one do I know?
10. Or the third one.
Third one is 10, right? So if I go from 10 to the 4th term, what would the fourth term be? 5, right?
Because you have it.
Oh.
Mm-hmm. What would be the last term?
2.5.
2.5. Good. Well, if I go, as I go to the right, I multiply by 1/2, right? But if I go backwards, what would I be multiplying by? Multiplying by 2. I like that. So what would be the second term? 20, which makes the first term 40. There's your 5 terms.
Wait, what'd you do?
Okay. This is the one.
Yeah, because after the 20 is 10. Yeah, okay. Well, thanks.
Gotcha. Alex, I'm good. I'm good with you. I don't know why they were laughing.
I'm not.
Because they're wait, so a sub 3 is 10. Then half. Oh, okay. So just, what's half of 2.5 though? Or does it not matter?
If you kept going to the 6th term, you could. 2.5 times or divided by 2 or multiplied by 1/2 would be like 1.25.
But
So you flip it.
So you don't want it 5 from that number. You want just 5.
It says yeah. So write the first 5 terms. So you would.
So you flip it. If you're going to the left, you're multiplying by 2. If you're going to the right, you're multiplying by 0.5.
Correct.
Okay.
And if you want to, just check it and then say, okay, so from 40, as I go right, I should be multiplying by 1/2 each time, right? And if you're not multiplying by 1/2 to get to it, you did something incorrect. That was it. All right.
5.
Are we good?
Mm-hmm.
Cool. All right, so we did unit 4. We did finish unit 4. Okay, we could go back to unit 5 before we do that, though. What was the other unit we have not done yet?
It was 2 and 4.
Yeah,
Like,
also.
Wait, did we do 2?
We didn't do 2.
Are y'all good with hitting on 2 real quick?
No, we did not.
I believe 2 is very, very short. It's like 5 problems.
We did 1, 3, and 5.
Yeah, my problem with unit 2 is that I couldn't read them.
Apologize.
Is it hard to read there?
Yeah, they're like.
Oh, I do see that. Yeah, it is tough. Let me go back, and maybe this will be easier to see if you put them here.
Like I was what a big distance was.
Wait, what are we doing?
Oh, yeah, it is tough. So this should be x to the 3rd plus 2x squared minus 15x over x squared plus 8x plus 15. See that? Over here, this is x to the 4th. Can you read this one, Jacob?
Yeah, it's mainly number 5. I like can't read all what it's saying.
Let's do number 5. Is that cool?
Yeah.
So this would be, well, that was good. I like that. So 4 to the x minus 5. 4 to the negative x minus 5 is on B. 4 to the x plus 5. And 4 to the negative x plus 5. This is equal signs right here. Okay. All right, so let's talk about a couple things and see if we can maybe talk through this. If I were to get just a graph, right? Basic graph. And let's say on that graph, we were to do a regular exponential graph. What would be the horizontal? 0. Good, Chris. We got it here. And if it was positive, where would it rise?
Rise right, fall left, like that.
Exactly. Rise to the right, and yeah, it kind of levels off to the left side. Okay? All right, so what we're going to do is we're just going to pretend that this graph is a y equals 4 to the x graph. I know it's not perfect, and that's okay. but we recognize that 4 to the x is what we're focused on, right? But the question is what transformations are occurring? Now, real quick, if I did, this is before I get to all of this stuff. If I did 4 to the negative x, what would happen to this green graph here?
It'd be like this.
Kind of, yeah, so it would actually be, since the x is negative, it would reflect over the y-axis, so it would go this way. So it would actually look something like that.
It's not that one.
Cool?
Wait, could we just plug this theoretically into our calculator and just see which matches?
This one would be without a calculator on this one.
Wait, so there's a, is it like 2 different ones?
That's a game changer.
Yeah, there will be two different ones. I would say again, I'm not trying to trick you on this. So when you go to the without a calculator part, just remember to like, okay, I've got to be able to do this without.
Well, okay, if that is y to the 4x, isn't it just going to be minus 5? Because it's going to go down.
Correct. It's exactly right. So if you notice that if you start from here without any transformations, which is this, right? 4 to the x, and it always will look something like this. Then ask yourself, what would I have to do to this graph to move the horizontal asymptote down 1, 2, 3, 4, and 5? Because it's the same graph, right? You see that? It's still the same graph. We just shifted everything down 5. So what would I need to do with that equation? Minus 5. Is it on with the x or on the outside?
It's like on the outside.
On the outside, good. Because on the outside, that is a vertical shift. It would actually go down 5.
So you know it. Okay.
So how to shoot plus
Okay,
5?
sorry, that graph is hard to read. I did not get that we weren't 0.
Oh, it is hard to
Wait, so
read.
Crochet, if it's a plus 5, then it goes up, or if it's plus whatever, it goes up.
Mhm. That would mean that would go up.
So what if it was like 4x minus 5? Like an x?
It was 4 to the x minus 5.
Yeah.
The 4 to the x minus 5 shifts that where?
To like the right.
Right 5. Good. So it would still remain here. You would just see this graph shift to the right 5. It's a good
Wait,
question.
so on the graph you have like on the sheet, why is negative 3 relevant?
That's just like, it's showing you how far it is. Like this right here.
Oh, I thought it was like at negative.
Does that make sense,
Yeah.
Parker? I know it's weird. Yeah, so I don't like that either, Parker. I see where you're coming from.
Like I thought that meant like that y was negative 3. You know what I mean?
I see. This just means you're going to go to the right 3 and left 3. And that up here means that this is at 1 and down this is at negative 6.
So is that that's 6. So is that the line that's right there? That's the asymptote.
Right here, yes.
Okay, I thought. Okay, cool.
Yeah, that's weird, I know. I hear what you're saying. Question. Here's a question on this one. When I would go to a log, okay? So like let's say it's either ln or log of x. What is the vertical asymptote? Here.
0.
0, right? So we would have something at 0. And what would the graph look like?
Like this.
Go like this, right? Okay. So how would I shift this left to? Yeah. So what would I do with this?
+2.
Let's say this exactly. Inside, if I was shifting this left 2, you would have ln of x plus 2. That would shift this left 2.
Why do you know it's a vertical asymptote?
It's just something we know.
Okay.
On
It's
that.
on the front of the sheet.
You gotta know it. Just because, okay.
Is it on there?
Yeah.
Let me see if I put it on this one just in case. Can I put it? Oh yeah, so here I actually give this to you right here. Traditional log graph.
How many pages is that?
It's here. 2.
All in common.
This
I have a
third one's
question.
kind of nothing. Yes, ma'am.
On unit 5, is it gonna be super graph heavy, like, or would you just ask us to put something in standard form, or like when we put it in standard form, we have to graph it?
You'll do both.
So
Now
it's a lot of graphing.
there are some parts of the graph. There's 3 graphs at the very end. Okay, I'll give them to you right now. I'll give them to you. Problem, You know how to graph an ellipse/hyperbola. And then the third one, remember the rational expressions where you have like a whole vertical asymptote? You'll need to know how to do that as well. Okay? The challenge questions would be finding the asymptotes of a hyperbola, and then also finding the slant asymptote.
Can you repeat that one more time?
Yes, so hyperbola,
Wait,
parabola.
the first part. Like that.
The rational expressions, the whole, that sort of
Yeah,
thing.
what's that?
That's like, and we could do one here in a second. I think it might be here.
It's unit 5, right? Or
It's
two?
actually right here, unit 2. So I'll actually do this. I'll do this and graph it.
Oh, another question. Is your
You good?
exam grouped by units, or like does it have a title for like you know how this is like unit 1 is a question, or is it just all mixed in?
I think it's all mixed in, but it seems more intense than what it really is, if that makes sense. Like when you see something that's find all the zeros, I mean, it's kind of,
Doing that one?
you know what I'm saying? Like they don't really mesh as much. Like the instructions help you like find the sum of an infinite geometric sequence. Then you know where you're headed. You know what I'm saying?
Okay, so
There's probably gonna be like 5 or 6 questions each unit, right? Give or take.
Give or take. I mean, it definitely varies. Definitely varies. Okay, so are we good on that last one? Parker, are we good? Did that answer your question?
Yes.
Okay. Can we start on number 1? And then someone said number 2, which is perfect. We'll do that one as well. Alex.
Is n is the exponent, right? And a is the coefficient. I'm not talking.
Yeah, n is the exponent.
Okay.
And then a sub n would be like the coefficient in front. Okay, let's do this thing. Could I graph number 1? You ready for this? Okay.
Take out the a.
First thing, what do I do anytime I have these, whether I'm graphing or I'm not?
Factor.
Factor, right? What can I take out of the top?
X.
An x, good. So I'm left with x squared
Plus 2x
minus
minus 15.
15, good. What about the
You
bottom?
factor out that
Yeah, what would that turn into?
part.
Good. What does the bottom turn into when factored?
Wait, is it x plus
It's
5?
x plus x plus minus 5x plus 3.
The top is not the bottom.
Top is fine.
Oh, I thought we were doing
Wait.
x plus 5, x plus.
Correct. Parker, did you have a question on something on the top?
Yeah.
Just what 2 numbers multiply to get here, right? But add to be here?
Right.
It's because 5.
5 minus 3.
Negative 3 is negative 15, and 5 minus 3 is 2.
Does that make sense?
And then,
So-
so those are going to be holes. X equals -5.
Good. So as I cancel here, right? We understand that when I cancel these, that's automatically a hole, right? So I'm just gonna write down these things. Here's what's cool about the test. I think I'm pretty specific by saying if I want you to find all these things, I'm gonna list them. It's like find the hole, find the horizontal, right? You'll do all of those things, but I'll give those to you. Here it kind of does, but it says all of the asymptotes and all the holes, so you kind of have to remember it, which is a little tougher on this one. What would be the hole up here then? Good, and I don't plug them in for this one, right? Because these were canceled, so I plug them in for x here, right? What does the bottom turn into? -2. What about the top? Yes. So the -5, right?
Yes.
That we canceled out from right here. When we canceled that out to find the y of the hole, we plug -5 back in for x, and then just simplify it out. So we get -5 times -5 minus 3, which is -8.
So the hole is whatever you cancel.
Correct. Right. And if I don't have anything that cancels, there's no hole.
Okay.
Right. So then we would get 40 over -2, which would be -20. So that would be the whole of my graph there. Okay. All right. Any vertical asymptotes?
Isn't it whatever makes it 0?
Say that again. Jake?
Whatever makes the bottom denominator equal to 0, isn't it?
Good. Yeah. And so this one would be
-3.
-3. Good. So we'd say x equals -3. Nice.
Wait, why is it negative? Do not set it equal to 0.
No, it's whatever makes it equal to 0.
Correct, we would. So both of you said the same thing, we would. So when we make the bottom equal to 0, right? That would be -3 on that. Okay. Remember the bottom, the 0 can't be in the bottom. So that's why it's what makes the bottom what we call undefined. Okay. So we got our hole, we got a vertical. Okay. What about the horizontal?
There is not one.
Yeah, why isn't
Where
there
do
one?
what? The X's are the same. Like they're.
I would come all the way back to the original one because you can do it that way. And because the top degree is greater than the bottom, you would just say that there is no horizontal. We just say none.
Are those rules on the new formula sheet, or do we need to know that?
They are, and I'll show you just so you can see them here. They're actually right here. I think they're actually
Go through them real quick.
better. The rules,
Yeah.
is that it? Yeah. So you see these here, Alex? If we're talking about the n and m, which is the degree, which is the highest exponent on the top and the bottom, okay? If they are the same, n and m, got me? The number that's in front of that highest exponent, we divide. If they're the same, we just divide them. If it's greater on the top, right here, if it's greater on the top than the bottom, then we would say that there's no horizontal asymptote. But if it's greater on the bottom than the top, we would say the horizontal is at 0. Okay?
Okay, so if the bottom is bigger than the top, it's 0.
0.
And if the top is bigger than the bottom,
None. And if it's the same, we divide. Okay? Cool. How do we think? What do we think so far? Okay?
What's if on that?
This just represents the degree, the nth degree or the mth degree, which is like the bottom of that. It's just what they use to be able to explain the rules that are there.
Do you have that printed out for us?
This will be the actual formula sheet here.
Right, that's what I'm saying. Will
Oh,
that be
what's
printed
the
out
vote?
for us tomorrow?
It will
Yes.
be. Yes, ma'am.
what's the rule for that? The rules for vertical?
Vertical, there's not really a rule that's on the formula sheet. That's more conceptual, like you just got to know it. That's just making the bottom equal to 0,
Okay.
excluding the hole if you have one.
Okay.
Okay. So notice the 5 is gone.
Yeah.
Only what makes the bottom equal to 0. Think of it as undefined, right? What makes the bottom, which would be undefined.
And then, okay, vertical asymptote. Where am I looking again? Am I looking at the bottom or the top?
The bottom. Think of this. Think of where can 0 not be? Can we have a 0 on the top of the fraction?
Oh, well, if you just set the bottom equal to 0, then that's your.
Perfect. And what you were saying is exactly right. I would just say, think of this as like, someone told me this, NO. I don't know if that helps you, but that just means the bottom is what creates the vertical aspect. Good. How do we feel?
Can we?
You gotta do a slant. though.
Yeah.
Okay, we can do a slant asymptote. I'm going to do it now. That's it. Y'all are here, so I'll tell you. It's a challenge question. Okay? Challenge question. So here's the thing. I want to do, I'll do that at the end. Let me do the slant and then we'll go. Okay? When we have a 1 degree higher on the top than the bottom, we can have what we call a slant asymptote. Okay? To do this, we literally take the bottom and we divide it into the top. Okay? So notice that only can happen. Can you have a horizontal and a slant asymptote?
No.
Why?
Because I don't know, because they'll contradict each other.
They contradict, right? Because look, if it's 1 degree greater on the top than the bottom, right? Then that means the top is greater than the bottom, which means you can't have a horizontal. Does that make sense? Right? Okay, so we're going to divide the bottom into the top by going x squared plus 8x plus 15. And it goes into x to the third plus 2x squared minus 15x plus 0, right? Okay, question. What times x squared gets me x to the third? X, good. X times x squared is? X to the third. X times 8x is? Good. And x times 15 is? Good. What do I do with this? Change the signs. Good. Good. And then this is going like a freight train. What's the bottom? Or what's this part now?
Negative 6x squared.
Negative 6x squared and think that's minus 30 because there's two
Yeah,
negatives.
Um,
Okay. All right, and then we bring down the 0. Okay, you ready for this? All right. What times x squared gets me negative 6x squared? Negative 6, that's your slant.
That's it.
That's all you have to do. Notice I just stopped, right? Cool. Because look, when I go, the remainder, because you're going to get a remainder, it doesn't matter what the remainder is. That's the slant asymptote. Okay? Got it? So it's a little different. Now, don't do that on one where I say divide and it's the long one, right? The one we did yesterday.
Recorded that, right?
But this one, we're good. Yes, ma'am.
All right.
Sure did. Doing this, do you want to try to graph this thing?
Do we have to?
There might be one that you will have to graph. I don't know if it'll be like this, but we could just graph it just to double check. Is that cool?
Sure, why not?
Just go through it. So the where's the vertical asymptote?
-3.
Good.
X
So x equals -3. Where's the hole?
-5, -20.
Oh, that's a mess, right? That's way over there. So we know it's -5. It's like way down here, right? Right. What about the slant?
X -6.
Okay, so where's the y-intercept?
6.
-6, right? 2, 3, 4, 5, 6.
Why is that negative? Don't you set it to 0?
Well, I see what you're saying in terms of, yeah, normally like if I'm finding it, but this right here is like y equals mx plus b. So it's like graphing a line kind of sort of. Okay. Like what would be the slope here?
Rise one.
Did you do quadratic for that too?
Rise one, learn one.
Yeah, rise 1, go over 1, right? And Jacob, you were saying quadratic?
Could you do quadratic instead of long division?
For the slant asymptote, no on that in this one. I see what you're saying. Now, if I were to do something else with zeros, yes.
But isn't slant asymptote a bonus though?
It is. Yes,
Oh,
it
so
is.
you don't have to do that.
But it's a good one. I mean, it's good points out there, right? I'm giving it to you. So it's something if you want to, you know it's coming. That's just how you would do it.
So do we have like 30 real questions or 30 questions plus a bonus?
Yeah. Is there like?
No, it's built in. So what I'll do
So
is
we
I'll
have,
give
like,
you
25 questions?
I'll give you a question very similar to something like this, let's say. And then I'll say, find the holes, vertical asymptotes, and horizontal asymptotes. Boom, boom, boom. Good. And then I'll say for a challenge question, tell me what the slant asymptote is.
Is he saying is that part of the 30 or is it 30 plus challenge?
30.
Like, are
It's
you
part
gonna
of the
use
30.
this as the base problem, but you're just gonna tell you that like the slant is like the challenge part?
So let's say this was number 30 on the test. The challenge question will be part of number 30.
Okay.
There's a part that you have to do, but then there's a part that you could do.
Okay.
So it's like 30 questions, but they have like multiple parts.
Not all of them. No, not necessarily. This one will, just because it is kind of based on each other.
Yeah.
Some are not that way. You know what I'm saying? That'd be good. There's something else I was going to say, and I was going to. Oh, by the way, what's the domain of this? Oh, I'm actually not done with this, am I? Come back. Okay, come back. By the way, this one seems long, and it is. Okay, I'm kind of incorporating a lot of different problems into one. Hopefully, it helps you there. So, rise 1 over 1. All right, we'll have something that looks like this. Okay, and then what I would do is, if you were to graph this, just plug some numbers in and just see what happens. So if I plugged in 0 into my equation, what would I get from there? Okay, and then just do like a T-chart that's off of that. Like if I plugged in 0, I would get 0 over a number.
Wait, you plug in 0 for the original or for the new one? Okay.
Either one would work. Either one would work here. I would say the original would be, or the new one would be easier for
Wait,
you.
also, could we just find the x-intercepts, the y-intercepts, like to graph it instead of plugging in?
It's absolutely fine. Yeah, like where y-intercept plug 0 in for x, right?
Yeah.
Which is kind of what I did. I just didn't call it that. And x-intercept plug 0 in for y, right? Yeah, absolutely. Go ahead and attack it that way. But this would end up, just so you all know, because we're going to keep going on problems here, but it's going to end up looking something like this, where it's like a parabola on the inside, and it would be like a parabola down there by headroom. Cool. Kendall, did you have a question?
Yeah. So like when you're plugging in 0, like when you're plugging in numbers, just for time point, you plug in 0 for x. Oh, are you plugging in for x or y?
X.
So you plug in 0, and then for y you would get 0 over 3.
Correct. Which is
0.
which is 0. Because it's okay
Oh yeah.
to have it. It's NO to have 0 on the bottom.
Okay.
Gotcha. Good, good. All right. Hey, I went through some extra stuff there. I know if you were overwhelmed by this, then don't be. That's not the main thing. I'd like for you to know that. I'd like for you to get that. But again, that's something that just kind of keep in the back of your mind there. Number 2. What do y'all think? Let's do it. Go through number 2. What's up, Trey? See, man. All right, let's go through finding all the zeros here. All right, first off, it's a calculator one, right? That's on purpose. There is a difference between number 2 and you see on number 5, it's a little different. On this one, it's a no calculator one, right? Because what's the first 0? See Chris. See you, Rita. Have a good day. 2, it's given to you, right? So what am I going to do in order to execute that?
Synthetic.
And we're going to plug that in, right? So we're going to put 2 in for synthetic, right?
Yes.
By plugging it in, exactly. And once I do that, what would my remainder be?
Like, I don't know.
You want to try? Let's do it. Could I do this one? It will kind of catapult us to the next one.
Wait, this is 5 on
Unit 1.
We're doing 2.
Is this one?
I know we just didn't get to this one yesterday, I don't think. I'm sorry.
What unit are we in?
Unit 1. Are we good on that? We don't have to do this one.
Oh, we can.
Are you okay?
Wait, did we do number 2 on unit 2?
We're not. The reason why I'm going to get there, I think this one is going to help us with where we're headed.
Which
Does that
one
make
is
sense? This is 5. But notice this is no calculator one. Okay. So this is much different than where we're going to head, but still similar process. So 2 gets plugged in for my synthetic, right? What goes next to it? 6, and then
negative 23.
Yep.
15, 14.
Nice. And what happens in the first one? 6 goes down.
12, and negative 11.
12, yep. Negative 11 here. Gotcha.
22.
What's up, Matt? 2 times negative 11 is negative 22 here. Good.
7.
We get negative 7. Nice.
14.
Negative 14. And 0. Is that surprising?
No.
Why?
Because it told us 2 was 0.
That's right. If you got something other than a 0 and it tells you it's a 0, you did something wrong. Okay? So you got 6, negative 11, and negative 7. So what do I do with this?
6x squared
Yes.
minus 11x minus 7.
Good. So what do I do with this part?
Factor it out.
Factor out if we can. Yes. And if we can't, what's up, Kai? Good to see you, my man. Bugs. So we could do that. We could do quadratic, right? Whatever one kind of floats your boat there. Either one will work. I think most of the time.
Go over AC method again. I don't know if this works, but like just in different.
We can.
Is that the answer?
We can. We can take this further though. Cool.
So
What's
yeah,
A times C?
it's going to be 3x minus 7.
A
For the
times
factoring thing.
You did that.
Slow
Yeah.
down.
Sorry.
What's A times C there, Ken?
Negative 42.
They are. So we got negative 42. What goes in for each of these?
Negative 42. Oh, yeah, I don't know.
Whatever the A is,
Oh, okay.
that 6x gets plugged in
Oh.
for each of those.
Christian, what are we using the A times C?
It's first time lots.
Some people do it that way. Some people do the check and guess method that way. This A times C method gets me this right answer every time. With these weird ones where A is greater than 1. So if you wanted to do it this way, you could. You don't have to. But you would put 6x in for both factors, and you would multiply A times C, hence A times C method. And then we ask the question, what times what two numbers multiply that equal negative 42, but when added equal negative 11? And
12 and something.
6. I think we're gonna have to break that down a bit more. Like break the 6 down.
Can't you just use the quadrant?
It's 3x minus
I got
7 and 2x plus 1.
Yeah.
say that again, Parker.
It's 3x minus 7 and 2x plus 1.
That's
Like
exactly
how
right.
we-
That's exactly right.
Like how we get there.
If we get here, well, two numbers would be 3 and 14.
Yeah.
3 and 14.
Yeah.
So if that's true, we put 3 and 14 here, where what two when they add to get equal to negative 11, what would need to be negative? 3 or 14? 14, right?
Yeah.
And then what can I take out of this?
3.
3, which leaves me with
2.
plus 1, which is what Parker said and Kendall said. And then what can I take out of 2x or 6x negative 14? 2, which would leave me with?
3x minus 7.
Good. There you are. So when I set this equal to 0, what would this be?
1/2.
Negative 1/2. Good. And then this one would be?
7/3.
7/3. Good. So we got 2, negative 1/2, and 7/3. Good. Gotcha. Do we understand the process of it? Here's the thing. I told you just the whole thing is you're trying to be perfect. You're going to mess up. There's probably going to be something you're going to mess up on because there's a lot of different parts to this. But if you can get to here based upon the fact that this is a 0, right? And then at least show work here to see how you could get to these two, that's good. That means you're headed towards the right process. You're going to get points back on that, all right? Just try to show as much as we can to kill.
How would you get 7/3?
You see how I factored them here? 2x plus 1 if I set that equal to 0.
Oh, that's good.
And then I could just subtract 1 divided by 2.
Wait, so when you take out the 3 and the 2, it just disappears?
It's part of that process of A times C.
Okay.
I know that's weird. Normally we pull it to the outside. You're exactly right, Alex. Just a part of this process. It's not, you're right. It's not really a mathematical, like usually we pull that at the outside, but just a part of it. It gets you the right answer every time. We just know that those two are getting thrown out once we do that. Only for this, right? Only for that. Okay, let's go to that other one. Are we good with that? Okay. Is it cold? 68. Is that?
Oh my god.
I like it chilly. I get like moving and yeah. What's that?
We keep it on 74 at my house.
74?
Yeah.
That's hot.
That's what my mom
My wife actually, I was checking it out the other day and it was like 74 or 5 in her house. I'm like, yeah, what do you like? I'm like it cold, you know, like I like it chilly.
I would catch a cold.
One of those things. Okay, let's do the calculator one. The difference between 2 and the other one we just did, okay? This is unit 2, number 2. The difference between the one we just did and this one is I did not give you the first 0, right?
Oh, you did kill you.
But I did say you could use your calculator, right? So if I do that, then let's use our calculator, right? So what we're going to do is we're going to literally plug in what we see here. So x to the 4th.
And then, would we like graph it?
And we're going to graph it exactly.
It's negative x.
Or is it equal?
Zero.
No.
It should be equal right
Yeah,
there.
It's giving me every time.
My printer's weird. Plus 10, x to the 3rd. Plug that in. What in the world?
Have you done unit 5 yet?
I did. Yes, ma'am. We can go back to it here in a second.
Okay,
Is that
I
cool?
was wondering.
What I'll do is I'll finish unit 2 and I'm going to stop the podcast. And then I'm going to do more individual stuff.
Okay.
Y'all have any other stuff that you need?
I'm gonna leave, but I'm gonna come back. I'm only a second.
Gotcha. What time are you coming back?
In like 30 minutes.
Oh, okay. Gotcha. 5x. Perfect. And then minus 66. Okay. So do you have that in? Okay, so now what do we do? And I think I messed up. I forgot to put something in here. What in the world? Come on, coach. That's minus. Sorry, I'm trying to put this in here and it's not. 10x. 10x squared. Yeah. Did y'all check me on that? Is that what you got?
Yeah.
Mm-hmm.
Okay. So we're gonna graph this. Now, is there anyone that I'm gonna guess that you probably don't see something like this? You probably see something like if you went to Zoom Standard, it probably looks something like this.
Which one are we on?
Right here, right?
Which one is similar?
This is number 2 on unit 2. Yeah, it kind of looks weird. Go to Zoom Standard for me. Just go to Zoom Standard. Start with that first. Okay, Kendall, do you see something?
I have a question.
Yes, ma'am.
How do we know like how many zeros it's supposed to be?
How many zeros they could have? Okay, good question. On this one, how many solutions will I have?
4.
4. I'm going to try to look for 4 of them, right? Good. So I know I'm headed that way. Now, you may not see 4 points on my graph, and that's okay. But we're going to get as many as we possibly can see.
I put it in for the y equals, and then I just went to the table and I was just looking at
Actually, that would work. That would absolutely work. Actually, I might adopt that. Do you want to do Kendall's method or my method? I think Kendall's method might be better. Here's what I'm going to do. I'm going to allow you to choose. So I'm going to show you my method, and then I want to show Kendall's method because I think hers is also probably easier for a lot of us.
The issue with that is that you don't know, like, if you have all the zeros, because I don't know, because there's like 4 that it could possibly be, but like I just don't know if I should like keep going up.
So you just go to the table
That's a good point.
and then find out
Where it hits 0.
Or
Mhm.
y 0.
Oh,
Let's do this. Just so we'll start with this, and then I'm going to go to Kendall's method. Okay, something like that. I do.
Yeah, that's how we're supposed to do it. I think you're supposed to go to the table and see where it says 0.
You could also go to the graph too, right? Like right here, what do we know about the 0?
Where it crosses.
Crosses, right? It starts at 2. So we know 2 is a 0, right? Also, as you see this here, if you go to Zoom and you want to go zoom out here, just again, once I say zoom out, I might just kind of back up just a little bit by pressing enter and just see, does it hit again? And actually it does, doesn't it? Where does it hit? Negative 11. So that would be a 0 for where we're at, right? So we know we have 1 at 2. And we know we could have 1 right here, which it's hard to see where that would be. How could I find that 0?
Do trace, second trace.
Good. Go down to 0. And then this is where I would go. See if I could find it here. Oh, hold up. My fault. I was looking at the wrong one. You see, the problem with this sometimes is you see this is where it's at, right? We want left bound, so we want it right above there. So when we go, it is above. As you notice, it's positive. So you can press enter there, press right, press enter, and then press guess to get that it's negative 11. Do you see that? However, like with what Kendall was saying, how do I know like when I finally hit a brick wall, right? When finally enough's enough. Well, here's what I would say. You could definitely find them this way and see that I've got 2 and negative 11. But if I went to the second table here, we can see that where is the 0? 2, right? 2. And if I wanted to go maybe further to the left side, I could go to second window. And instead of the table starting at 0, I can start it at like negative 20. And that way I can kind of scroll through a little bit easier. So if I go down from negative 20 and just keep going down, what do I see? Negative 11 is a 0, right? So we can go down. So first off, if I get to this and I did Kendall's method and I see that negative 11 is a 0, stop right there. And what I'm going to do is I know that negative 11 when plugged in synthetic will get me what?
0.
0. Good. So let's start with that. So we plug negative 11 in, and we got 1, 10, negative 10, 5, and negative 66. Very similar to what we just did. What do I do with 1?
Bring it down.
Bring it down. What do I do next? Multiply to get. Good. Add it to get. Good. Multiply to get. 11.
Whoa. Yep.
Did I mess up there?
No, that was me.
So then we add to get 1, right? 1 times negative 11 is? Good. And add to get? Negative 6 times negative 11 is? 66. And there you go. There's a remainder of 0.
Ooh.
Okay.
Oh. X cubed minus x squared plus x minus 6.
Correct. That's exactly right.
So you just keep finding zeros and doing that division.
Correct. And especially, it's really until I get to where it's x squared. Because once it's x squared, I could factor.
So we can
Or
do 2
quadratic.
now. You can put 2 in for like a little box.
Mm-hmm. And we remember based upon what Kendall said, right? Her method. You like how I named that method after you? I like it.
Kendall's law.
We remember that when we looked down, we recognized that there was another one, either by the graph or by the table. So then once I plug 2
Whenever
in,
y is 0 on the table, you can do that.
say that again?
So whenever y is 0 on the table, you can take the x value.
Correct. That means it's a x-intercept, right? 0 there. That's exactly right. So what do I do here?
Bring down 1.
Good. Can I do it with the simplified?
Yes.
Yes, I would prefer that, right? Prefer that. Bring down a 1. Multiply to get.
2.
Add to get. Good. Multiply to get 2. Add to get 3. 3 times 2 is add to get
0.
0. And we have a remainder of 0.
So then you have x squared plus 1.
Good. Right there. So what do I do with that?
Factor.
I could. I don't think I can factor this one. Quadratic.
We wish.
So, well, first off, question, because this is a longer process one. Is everyone good with how I got here? Like you got them from your graph, we plug them in, right? Simplify. And then we just do x equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? So what's b? Negative 1 plus or minus. What's b squared? 1 minus 4. What's a times c? 3. All over 2 times a, which, what is 2 times a? 2. Yeah. What's inside this parenthesis? Negative 11. Good. And if I have the square root of a negative 11, what happens with that? Good. Good, y'all. I root 11, right? And then, so we have negative 1 plus or minus I root 11 all over 2.
Would you like us to separate it up, like negative 1/2 plus or minus I root 11?
Over 2? That's actually a good point, Trey. I will take either. As long as you simplify, right? I would actually, for simplification stuff, I would say that would be better. Because then you could divide each separately, right? If you needed to. But that's good. That's good stuff. Cool. All right. What do y'all think? It's a lot, right? We've gone through a lot. I think we've gone through every type of problem in the 2 study sessions there. I think we've gone through every type of problem. Number 3 is the same thing we just did, right? Same idea. Trying to see, is there... You're losing it? You've been focused. You've been focused in. I appreciate you.
That's not bad.
Number 4?
I
Yeah.
forgot there's, like a lot of these you forget how to like start them. That's so long.
Up to you. I can do whatever y'all need to. If you want to, we could just go through, hey, how would you start each one? If you wanted to. And just say, okay, how would you start this? All right, I would start on my calculator and go here. Perfect. Okay, next one. We can do that if you wanted to later on. You want to start with number 4 and then I'll do that to wrap it up? All right, so number 4, question, what type of transformations are occurring on number 4?
Good.
Down 1.
Left 2.
Down 1, good, and left 2. So I would say, just put a little note here. Down 1, left 2. And largely, if you mess it up, that just helps me to identify that you know what you just did. with those
Yeah,
transformations.
it's gonna flip.
It is going to flip. What I would do is this, Scott, and you could do that. You could flip it at the end. I would say just graph -3 to the x first. Okay? Then we're going to transform it this way. Okay? So question, if I were to create a little T-chart here, what would I plug in for x? I like it. -1, 0, 1, and maybe 2 if you need to. So what would be 3 to the negative first? Because the negative comes last, right? Because it's not in parentheses. 3 to the negative first is?
That's a great question.
3 to the negative first.
1/3.
1/3. Exactly. Good,
But would
Kendall.
it be negative?
Was it negative 3?
It's 1/3, and then we include the negative at the end.
Negative.
So this would be -1/3. What's 3 to the 0 power?
1.
Then the negative comes in, which would be -1. Good. And what about if I plugged in 1? -3. Good. So we would have, again, I'm not done yet. This yellow one's not done, but it's a good start. We've got -1, -1/3, 0, -1, and 1 goes down to -3. Okay?
Good shit. I have to go to the podcast and how to start each one.
Absolutely. I'll continue with that. That's good. Thanks for coming, Parker. So what happens here?
They just shove everything over 1, don't you?
Right there. Okay. Where's the horizontal? Where's the horizontal asymptote?
It's gonna be 0, -2.
Well, it's at
Oh,
-1.
it's at 0 first, right?
-1.
With this one. Now, once I take this and go, each point's going to go down 1, left 2, right? So each of these points is going to go down 1. And I know my graph is off, but that's okay. Down 1, left 2. So it's about right there. Down 1, left 2. Down 1, left 2. Is that rough?
So where's the 2 come from?
Jacob needs a break.
Right here?
Oh, okay.
Jacob,
Right there?
Down 1 left.
Gotcha.
So in the exponent, the value's flipped. So those positive 2.
Correct. So since this is negative here, right? What normally would come up now is reflected down, right?
Okay.
And then once I transform it, this goes down here, over here. What's the asymptote now?
It's down 2 over 1. Which was down 2.
It's actually, well, down 1,
Oh, sorry.
left 2, right? So if it goes left, that doesn't change it.
Yeah.
But if it goes down 1, it would be at -1. Gotcha. And would that be x or y equals? Y. Good. Y equals -1 would be the asymptote, and the blue graph is what you would graph there.
Really is.
Yeah, good question. So if I said find the y-intercept, right? You plug 0 in for x, right? Well, we didn't do that yet, actually. So if we plug 0 in for x, what would we get out? Well, we would get -3 to the 0 plus 2 minus 1 at the end, right? Well, 0 plus 2 is 2. This is tricky right here. What would that equal? -9. Good, because it's not in parentheses, right? So we would say 3 squared is 9. With the negative is -9. Minus 1 is -10. So the y-intercept would be at -10. Be actually at 0, -10. Okay? All right, so question. Oh, this is a good one. X-intercept. You plug 0 in for what? Y. So we have 0 is equal to -3 to the x plus 2 minus 1. What am I solving for? X. Good. So how can I get x by itself? Correct. Almost, right? What do we do before that, though? You're right, Trey. Bring the 1 over first, which you were right. Add that 1. So 1 equals -3 to the x plus 2.
And then shoot
Log-
X.
Log
Oh,
both
no,
sides
log it
first,
and
and then shoot X.
Good. Then we log each side. Good. And what happens to the exponent?
Goes to the front.
Goes to the front. Man, y'all are. This is impressive. Good. Shoot it to the front. So you got log of 1 equals log of -3. And again, we have the x plus 2 right here at the front. I should have given more room here. But that should be x plus 2 there.
Divide by log.
Good. Divide by log of -3, which cancels. What I do to one side, I do to the other. Right? What's the problem with this? Correct. Okay. Now your process. Did you all do the process right?
Wait,
You're right. You did it perfect. Okay. Kendall, you got something?
so after you do x plus 2 log
-3.
then you divide by log -3.
Correct. And then once you do that, you could try to plug this in. But as y'all said, there's a problem here, right? Can you have a log of a negative number?
No.
I cannot. So what would I put?
0, 9.
Yeah, exactly. But look and see. So you would say for x-intercept, you'd have 9. But really, did I have to even do this in blue?
No, can't you just like look at the graph?
Correct. Look at the graph. Does it hit the x-axis?
Oh.
No.
Okay.
Now, is that good to know? Yes, because didn't we do one of those earlier on unit 3? If you looked at unit 3 right here, didn't we do one like that? Very similar. Y'all rocked it. This one you can actually do it with, right? But just note that over here, when you do the graph, it's possible that that's the case. All right. Whew, that was a lot of problems, y'all. Good work there. Parker and some of you said that it would be helpful, I think Jacob said it, to just walk through and say, how would I start? Mikhail, thank you for coming. Thank you. How do I start these, right? And just getting feedback from that on how you would start it and then go from there. We're not going to actually do all of them again. If we need to go through a couple of them, we will. But just for the podcast's sake, let's go through what's the first step, and then we'll rock and roll. Okay, Kendall?
I have a question about unit 3, number 8. This is like not what I just said, but
No, you're good. What's up? Right here?
yes. So it's when it says if it is false, correct it to make a true statement. Like for C, that's false. So what do you want us to do?
Yeah, I don't think I said to do that on the actual test.
Okay.
What I would say though is just to help you out in case we had one, 6 to the log, base 6 of 9, that would cancel there.
It's not basic, so it's just log.
Correct. That's how I would fix it.
Oh.
Does that make sense?
Okay.
To make it 9. That makes sense there?
Wait, which one was false?
C was false.
How long should we take on each problem? So
It really does vary, Scott. I know that's an awful answer. I would say just keep moving. I know it's like an awful response, but just make sure it's meant to be finished, right?
Yeah.
So as you go through, don't spend too long on any one problem.
okay, and you might have already answered this, but did you say it was graph heavy or not graph? Or like
I would say there's 2 or 3 that to graph
on the whole test?
on the whole test. Mhm.
But
it's what's up, Jackson?
William?
Jackson, everybody.
Shit.
Here we
Get
go.
out of here, William. What's up, Dave? I love you.
The guy that wishes he was graduating.
I did. I definitely did. Relax.
Gotcha.
Yeah, why are you
Okay, you ready? Ready for this?
here?
What do we do on each problem?
Got it, right. For this one,
Number 1, what would you do?
you have to plug it into your calculator.
Plug it into your calculator. What would you find?
You find
Where it like reaches its highest, and then where it crosses the
you do
x-axis.
the left bound and right bound and then
Left bound and right bound again.
center.
Or 0.
Good. Where is the zeros, maximum, minimum? How do I get there?
Second trace.
Second trace. Good. 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 What about synthetic? Are we good on that? Synthetic, right?
5, 2,
Exactly. Number 3. How do we do that?
What's degree of 4? Does that say degree of 4 behind your pitch?
It does. I know I'm too tall.
put it in like a little parentheses, you gotta multiply them out.
Correct. Good try. So we would put them in those parentheses.
Like x minus 3.
Yeah.
Exactly. What's one thing to be careful on here? What's
Multiplicity of 2, so you have to do x minus 2 twice.
x minus 2 twice? And just be careful when multiplying, right? Because it's easy to mess up. Just do one at a time,
What
right?
does the degree of 4 mean again?
That means that the highest exponent will be 4. Just something to keep in the back of your mind. Number 4?
Plug it in. Same, plug it in calculator.
And zeros, right? Okay. Number 5.
You put the 2 in the synthetic, and then you small out.
Yep. Plug 2 in, synthetic,
And then
And
quadratic.
factory. All right. Good. Number 6.
X squared plus 0x plus 4 on the outside.
Mhm.
And then let's go to the division.
Long division, right? Easy to mess up. There's a lot of steps there. Make sure you show all your steps out. Just be leery of that. Number 7 and 8.
Just eyes, just the eye rules.
Distribute, good. Make sure you do negative I first. Once I get that,
You do it together.
I'll have this. I'll have one here. And then I just multiply it by whatever the 4 minus 6i, right? What about here on the number 8?
Then you extend them out. So it's squared. So you do the minus 2i, then do it again.
Multiply that, get an answer. 4 plus 3i squared, get an answer. Make sure the negative goes to what part?
Wait.
Anything to the right. Changes every sign.
Do we do that at the end or while we're doing it?
At the very end.
Very end?
Yeah. Before you simplify,
Okay.
right? Before you
So
combine.
before you combine to the left side, you do it.
X and Y intercepts. Trey was helping us with this one earlier.
Wow.
What would be the X intercept? How would I find X intercepts here?
You plug
0 for
0
y.
in for Y, good. Or G of X in this case. And Y intercept, you plug 0 in for X, very good. And behavior.
That's what
It's on the formula sheet.
Formula sheet, just know where to go. Got me? Take a look at them. Make sure you have an idea of how to utilize that. If it's an even degree, but positive coefficient in front, what's going to happen?
Even degree, positive coefficient.
What would that
Both go.
in behavior?
Rise right, rise left.
Rise left and rise right, right? Good stuff. And what about if it was negative?
Both go down.
Both go down, right? And if it was odd, positive, what would happen?
Fall left.
Yes.
And rise right.
Think of positive slope, right? And if it was odd, negative.
Rise left, fall.
Good, good, good. Number 1, what do I want to do on these ones?
You gotta factor them first.
Factor them, good. If they cancel, let's say whole. That's the X of the whole, right? How do I get the Y? Well, whatever the X is,
yeah.
if it was 0, you'd be right. But let's say it was 3. Plug 3 back in to get the Y. Right. Vertical asymptotes are what?
Just the rules.
either-
Yeah. If top is greater.
That's horizontal.
vertical
right?
over, it's just at bottom equals 0.
Bottom is equal to 0. That's vertical, right? Slant asymptote is when you have 1 degree.
Bigger on the top and bottom.
Great, great, great. Find all the zeros. How would I do that?
Graph there.
Do the
Graphing
Line
calculator, right? We find the zeros, which was like negative 11 and 2, and then we do synthetic, right? Plug it in, simplify it out.
You
We
do
did this one too.
The 2 would be on the bottom of the negative 11, right? You do the synthetic.
Say that one more time.
How you like combine both synthetics, is that right?
Does it matter the order?
Yeah.
Actually, does it? We work both ways. Work both ways. Okay. You did 2 first, you'd be good. If you did negative 11, you'd be good too. Okay. Just do both of them on that. Graphing, right? We said, first of all, take out the transformations. We already did this one, right? We just did this one. Take out the transformations. What type of asymptote will you have in an exponential?
I do not know. Horizontal.
Horizontal? A log would have a? Vertical, right? Good.
Thank you so much. Can you repeat that one more time?
Vertical for a log,
No.
horizontal for a exponential. Right? So that's that one there. Unit 3. What would I do on number 1?
Or you do the
log.
Log on both sides. Very good. On number 2, what type of formula would be used on number 2?
It's continuously, so
A equals PE.
Nice. And we remember that because we have a compounded continuously, right?
Wait, what you didn't say the numbers in that one?
The numbers of
Like,
the answer.
yeah.
Yeah, absolutely. I think I've got it right here. Trey, do you want my answer sheet?
Yeah.
Here you go. Got you. You can literally have this. For anyone that wants it, that's unit 3. Number 2, it is 9.9%. Right?
Does that have to work on it too?
It does, yes, ma'am. It does. You can take a picture of it, or I have them online as well. Let's have them online as well.
Do you have any extra copies of the review?
The review, I might have some in the. No, I've got one right here. I've got one right here.
Are you still podcasting?
I am.
It's been a long one.
It's a long one, right? If you're at home watching this, get out of bed, come here.
No, it's too late.
Stop being lazy.
hour,
Are you gonna
hour
like cut
2,
stuff out?
15.
Leave it.
Really?
Yeah, all of you who made fun of your friends, there you go. You got it right there.
They're not gonna.
And teachers?
And teachers. Hold up, did that happen?
Jacob?
Oh man, Jacob, I am so sorry, Coach Meeker. All right, what would I do on this one?
You combine the
Oh, you move it to the other
log,
side.
so it's like log 8 and then
The log
minus x.
I wonder if that would work. I think it would be a little easier to combine these by multiplying. Do you remember the rule of if you add 2 logs, you make it 1, right? By multiplying them?
Yeah, I put it I put it on the other side, like I subtracted log 8, 24x, and then I did log 8 times. Does this work?
This is scary. 6,000 was on the other side.
I did this.
I was just like,
It was a little lengthy.
It would work. I think it might be easier if you just combine them here to make it log base 8 of 7 minus x times 3x plus 5 equals log base 8 of 24x. And then since there's a 2 log base 8 on either side, just cancel, multiply it, and then it just would be a little.
It's a lot faster.
Does that make sense?
Yes.
But yes, that would work.
Okay.
Okay, what about, is this helping y'all? I don't know.
Yes.
Can we
It's
do
like-
that one? Can we do unit 3 number?
Kendall.
Unit 3, number 3.
Cheating.
Alex.
Alex.
You're a cheater.
Alex. I'm realizing that Alex is.
Or did you
He's
go
been
for
lying
that?
this
Did you
whole
do that?
time.
You should revoke his whole grade.
I
You guys
did.
should revoke
Yes, ma'am.
the title of
Oh,
this or GC.
Yeah.
Are you sure you want me to?
I will
Like,
humbly
we're on.
take
If you don't mind.
Is it cool if I stop the podcast? I'll come back to it.
Yeah.
Is that cool? So let me just finish off the concepts, just going through, and then I'll come back to it.
Okay. I'll circle it.
Okay. Top one
Oh,
right here.
the 2 goes to the x plus 1, and then the e and the ln cancel.
X plus 1 squared, right? What about 5 for vertical asymptotes?
Yeah, I don't know that one.
This one's remember a vertical asymptote changes from horizontal change, right? What's the horizontal change here?
9.
3x minus 9, right? So if I set 3x minus 9 equal to 0, right? It'd be positive 3,
Positive 3.
right? So my new vertical asymptote would be x equals 3
That's it. Oh, yeah, the intercepts too.
because it moves it to the right. And in the x-intercept, I put y,
Equal.
put 0 in for y.
Yep.
And then this is where I'm going to have to do the e, which is the opposite of the ln.
So this
right?
is a calculator one.
Not necessarily, because you'll have here, right? This is on the podcast if you check it out too, where I change this, right?
Oh.
Change this, and then I do e to both sides.
Yep.
And then 6 and 7, how do I do that?
Wait, that was unit 3. Wait,
These are just little rules that.
Log rules, right? Log rules. So just make sure you know how to condense them.
That'd just be like ln x3 minus ln y, wouldn't it?
Yeah, except that square root would be to the 1/2 power, right?
Yeah.
So that 1/2 would be to the whole thing. Does that make sense?
Yeah.
So just to start us off, you're right, Jacob. This would be the 1/2. 1/2 would shoot to the front.
What problem are you going?
You just go.
I'm just kind of going all over, like just step by step over how I would start each one. And then I would, you're right, and divvy it up with subtraction. Subtraction.
That should just be condensing, wouldn't it?
These here,
Or like number 7, I mean.
yes, condense.
It's just like 1/2. It's like 8 log, right?
This would be 16 to the 1/4 minus log base b of 5 squared. 16 to the 1/4 power is 2.
Snaps.
Right? That makes sense?
So you just move the numbers to the front. Okay.
Yep, and then you're right.
Because then you can get rid of the log base 10 or the log base b, can't you?
Well, because we're just trying to get it to where it's 1 log base b.
Okay.
And if I subtract them, that means the one that's subtracted goes on the bottom.
Oh, and then you
Added.
just have the one on over the one on top.
All right, these right here are just simplifying them, right? Just kind of rules, just kind of touch base on that. So this one would actually be true. This one would be true.
First one's true.
First one's true. This one's false. What about this one here?
Log.
You could take the log of both sides, right? Like we did earlier.
Log
But you could easily take 16 and make it 2 to the what power? Good, 2 to the 4th.
Oh, and then cross out the
2,
yeah.
and then
Oh, your question mark in there, is that just the way it?
Yeah, it's messed up. I don't know why it went through there. My fault.
Yeah.
Should just be 2. And then so I'll set 4 equal to 7x minus 5. Okay. Graph these problems. If you know how to do the ones that we did earlier, right? What would be the vertical asymptote here?
X equals 5.
X equals 5. What's the horizontal asymptote?
0. Oh, it's 1.
1. Good. So you'll see
Because it's
because it's the same.
Same degree, so it's whatever number is the coefficient.
Good. So
Did
you
make
got
a
that,
T-chart for
right?
these?
So again,
Do you make a T-chart for these to find the different points?
you could. Yeah, but really don't need a ton of points because if this is the horizontal, this is the vertical, right? You just need to know where it's graphed.
Okay.
Cool.
Oh, so
Once you know,
So once you get the horizontal vertical, you can just kind of draw a little line.
as long as you have 1 point in there, right? You're right.
So you just do 1 T-chart for the whole. Oh, you're good.
You're right. Mhm. This one's easier than the other ones, I think. Over here, these, by the way, okay, so here's we've already done these kind of sort of.
Mhm.
This right here will be an exponential, therefore it has what type of asymptote? Horizontal asymptote, and this would have a vertical because it's a log. Good. Unit 4, we've really hit on these pretty hard today. The big thing is identifying the infinite geometric sequence. Find the sum of the 10 terms, right? Is this geometric or arithmetic? Geometric because it's a geometric equation, right? What's A1? And what's negative 1/2?
Ratio.
Ratio R. Good. Here's the thing. I'm not going to go into number 3. Check it out on the podcast. Probably one of the toughest problems on the actual review.
Is that the
Need
one
me to go through it?
With
Is that the one with the triangle?
NCR?
Pascal's? Oh, no.
oh, I remember this.
Oh.
Oh.
Here's the thing. I went through that in a lot of detail on the podcast. Okay? Check it out. Very early in the podcast. Okay? By the first 5 terms, what does that mean I plug in for n?
5.
1 through 5, right? If I said expand this and simplify the binomial, what would I use?
Pascal's triangle.
Pascal's triangle. Good. Write a rule for this. Just make sure you go back through, and because we had a good discussion on that. Some of you were involved here. Go back through on the podcast on those.
Wait, so you just plug in 1 for n and then 2 for n?
Up at 4?
Yeah.
Yes.
Okay.
All the way to 5.
Okay.
Right.
So the triangle, how far down?
It's the fourth. It's one more than the degree.
The first one, the
That makes
very
sense.
first one is just
So
0.
it's the third, so you're gonna have the 4 terms, which is 1, 3, 3, 1. So the fourth power will have 5 terms. Does that make sense? Again, find the sum of the infinite geometric series. Check that out. Nth term of the sequence. We're adding by 5 halves each time. That's arithmetic. Check that one out too. Write the first 5 terms. As we go to unit 5, it's pretty self-explanatory with the parabola. What do we want to get it in?
You gotta get it with the y's and the x's, or you gotta put the x's on the.
Yeah, whatever's y, whatever's squared keeps on the same side. Everything moves to the right side. And then notice how to find the vertex, focus, and directrix. Find the equation of the parabola. Again, we want to graph this and then find it in standard form. Putting it in standard form, we're going to complete the square, right? Take out what's in common, complete the square there. Same thing, complete the square on this one. Just kind of know how to find center, the vertices, foci, right? You'll have all the equations. Just remember, right? What are we trying to find within each of those? Find an equation given the following characteristics. Number 6, is that a hyperbola? Or, well, it says it's a hyperbola. Why does it say it's a hyperbola? Minus sign in the middle. Good. And will it be graphed left and right or up or down?
X is first. So,
No.
X is first, so it's left and right. Okay, left and right.
Business class.
Okay, all right, good stuff. Number 8, throw out.
Yeah, get out of here.
And
it's Bobby.
number 7 is related to those hyperbolas. That's it.
Perfect.
All right. Well, I hope that y'all enjoyed the short podcast that was there.
Oh, wow.
We are on, literally, this was a 2.5 hour, go ahead. These were the few that were faithful. Those of you who are at home that are watching this.
Cameron, Mary, Nate. Ooh, good kill.
Michael.
Michael's
Just
not
saying.
watching this.
You might want to check that out. Anyway, have a good night. See y'all.